is the most critical data, what regulated data exists, where these critical data reside, are they properly classified, and who had access to them. And the next step, which is the building step, professionals will work with the client's IT team to transform the cloud security controls by helping them migrate and modernize infrastructure and applications based on the security best practices. They will extend beyond traditional networks with microsegmentation. They will help design, build, and run applications by integrating security at all stages of the software development cycle. They will they will test the application with the X-Force Red penetration test to defend against attacks. Next, they will move on to the run step, where they will help provide threat management and continuous security monitoring in order to identify, protect critical data, detect advanced threats, respond, and recover from disruptions. And finally, as the cloud evolves, there will be continuous improvement and adaptation, and therefore they will repeat all the previous steps.
For the use case, uh, the large global bank has used the X-Force Red, who are an autonomous team of veteran hackers within IBM Security, hired to break into organizations and uncover risky vulnerabilities that criminal attackers may use for personal gain. Well, large global bank had a lack of enterprise scale solution of vulnerability management. In fact, they had a complex spreadsheet system that extracted a large number of vulnerabilities, which led to a difficulty in deconstructing the reports and tracing the problem back. They had to review their vulnerabilities manually, as the system only gives them how many vulnerabilities they have and do not specify them. And after using X-Force Red, uh, the team had built a data model and fixed the data quality problems and added some automation, which prioritized the vulnerabilities that can be weaponized by creating a transparent automated ranking formula. And for that, the large global bank was able to attribute vulnerabilities to the proper remediations owners and more easily measure their performance over time. The use of X-Force Red has prevented attacks by remediating the vulnerabilities, and 44% decrease in total vulnerabilities, which are 60% of them are critical vulnerabilities.
So now moving on to Team Camry. It is an internet security firm that offers research services making the internet a more secure place. The company's service portfolio includes threat intelligence, enterprise intelligence services, executive briefing services, security intelligence, and more. They operate on their own internet server provider, and they are visible through their pure platform, Augury. Augury is an intuitive query tool that helps clients to correlate and analyze over 50 different data types, including the global internet traffic. The solution allows clients to trace threat actors through dozens of proxies and VPNs, map the extended infrastructure, proactively block associated IPs, then monitor these threats and defense against them. So the strategic value of tracking cyber threats is as follows. First, there's a continuous monitoring. They monitor threats beyond the internet enterprise perimeters, and they proactively block new malicious infrastructure as it appears. Then there's SecOps optimization. They accelerate the security operations center analysts' ability to filter out noise and fine-tune their security information. Then there's an incident response. They save time and money by quickly identifying all the compromised nodes and blocking the malicious IP addresses they're communicating with. Then there's a third-party risk monitoring. They identify malicious communication between third-party assets and cyber threat infrastructure. Then they move on to the investigation and attribution. They trace threat actors and cyber criminals through more than a dozen proxies to eliminate an evidence of path to the perpetrators. Finally, they provide a cloud security. They map your cloud footprints and monitor the landscape for abnormal communications.
For the use case, we have the mutually agreed norms for routing security initiative, who is responsible for implementing the crucial fixes needed to reduce the most common routing threats. Uh, before the introduction of Team Camero, they had 12,1600 routing outrages or incidents during 2019, such as route hijacking and leaks that led to large-scale distributed denial of service attacks, stolen data, lost revenue, reputational damage. With the intervention of the team, with their service unwanted traffic removal service that runs over BGP, known as the Border Gateway Protocol, which is the postal service of the internet. It is responsible for looking at all of the available paths that data could travel and picking the best route, which usually means hopping between autonomous systems. The company maintains searchable records of changes to the global routing table for audit purposes. For that purpose, the team will assist network operators in increasing their routing policy security. In fact, with their intervention, the visibility of routing security issues that have not traditionally been part of the computer security and incident response team portfolio will increase. Now we move on to Noor.
Actually, when we are comparing both, we notice that X-Force Exchange provides an extensive threat database that is searchable by a range of parameters: application name, IP, or URL. Team Camero is dedicated to compiling information about behavior from the atomic to the behavioral. Its portal includes IP reputation, lookup, and malware hash analysis. First of all, in order to protect against a threat, we need to understand it. This figure depicts the 7 phases of a cyber attack. We have the proactive phase, which is the reconnaissance, weaponization, and delivery, exploitation, and then the reactive side, exploitation, installation, command and control, action on objective. The cyber threat intelligence ensures that the organization are tested on their ability to prevent. Can you hear me?
Yes, now yes.
Okay.
Hello.
The threat ensures that the organizations are tested on their ability to prevent, detect, and respond to realistic, contemporary, and accurate attacks. So since there is a progression of preliminary steps and activities will go before a malicious attack, intelligence efforts can take place to recognize who may be targeting the network, what are the intentions and capabilities of the malicious actors, when they will conduct their activity, where the activity originate, and how they plan to penetrate or affect network. Now we move on to the character of cyber threat intelligence. By perceiving and drawing the enemy at the reconnaissance, weaponization, and delivery step of the cyber attack lifecycle that we named as proactive approach, that's the time to take the necessary course of action to protect the network and attacks. But it is still possible to avoid this response and recovery strategies. To be more effective in threat intelligence, the following characteristics should be adapted. It should be timely, it should be relevant, accurate, specific, and actionable. We are also going to move to the notion of cyber threat hunting, which is the procedure of proactively and iteratively seeking through networks to detect and isolate propelled threats that avoid existing security arrangements. Cyber threat management is much more than just risk assessment. It emerges best practices for managing cyber threats, which includes manual and automated intelligence gathering and threat analytics, a comprehensive methodology for real-time monitoring, including advanced techniques such as behavioral modeling, use of advanced analytics to optimize intelligence, generate security intelligence, and provide situational awareness. Technology and skilled people to leverage situational awareness and enable rapid decisions and automated or manual actions. This goes through a cycle from the observation of the threat and then going through a cycle of the organizational culture, internal and pre-incidental and organizational history, and then move into making the decision and then taking action. Now we're going to talk about the levels of cyber threat intelligence. There are mainly three levels, which are the operational, tactical, and strategic. For the operational threat intelligence, it often relates to details of potential impending operations against an organization. Cyber threat intelligence providers will generally supply operational threat intelligence in a combination of human and machine-readable formats. In the technical threat intelligence, it consists of material relating to the techniques, tactics, and procedures, TTPs, used by the threat actor. Indicators of compromise, IOCs, are the main deliverables for tactical threat intelligence providers. CTI providers will generally supply IOCs in machine-readable formats, whereas intelligence on TTPs will be in human-readable formats and will require human assimilation and action. For the third and last level, which is strategic threat intelligence, it exists to inform senior decision makers of broader changes in the threat landscape. Because of this intended audience, strategic intelligence products are expressed in plain language and focus on issues of business risk rather than technical terminology. And hence we notice that from a level to another, the language and the machine includes, gets more and more human and more simpler to discuss and analyze. The intelligence cycle goes through mainly 4 steps. The first is planning and direction, which is used to coordinate intelligence activities to most efficiently serve the consumer's requirements and should involve significant interaction between the consumer and producer. Second, it's the collection phase. It involves gathering the data and information that is likely to meet the identified requirements, understanding which sources are likely to produce the desired information, be reliable, and provide information that can be consumed in a timely manner, which is a complicated process. It requires good planning and a direction to help separate the signals from the noise. The third phase is processing and analysis, in which raw data and information is collected, fused with other sources, and turned into intelligence. Human and machine capabilities alike in this phase need to be geared towards answering the engagement while adhering to the principles of intelligence. Analysts will typically apply a variety of quantitative and qualitative analytical techniques to assess the importance and implications of processed information. They will then integrate it by combining disparate pieces of information to identify patterns and then interpret the significance of any newly developed knowledge. The fourth and last step is dissemination, which is the timely conveyance of completed intelligence products in an appropriate format to the intended consumers. The frequency of dissemination should match the time period in which the content is based. For example, operational material needs to be delivered frequently, whereas strategic intent will be intermittent. Via soliciting feedback and refining existing IRs or developing new ones, the intelligence cycle can begin again. We can move on to the next part.
Well, thank you for your attention.
So, thank you for your presentation. I have some remarks related to the presentation. It's a good work. Well, it's a good work, but it's not very well organized. Since I preferred that starting from the slide 14, when you were explaining the threats and threat cycle management, and all these were important to present them before the two solutions, especially for the your friends who do not have prior knowledge about threat management and threats and security. So I think that those who have followed the course of security will find themselves following you easily, but those who didn't have prior knowledge will not be able to understand until they reach the final slide. So I think that the slides from 14 to the 21, I think, should be presented before the two solution experts and SIMRI.
All right.
Hmm?
All right. I get the remark. I mean, we did that because we thought that it would be like easier to understand if we give them an example in which they use the X-Force or. But yeah,
Yes.
I understand your point.
I think because at the last, starting from 14, I think from 13, you said that you will differentiate the difference between, well, you compare express to summary.
Yes.
And starting from this point, you have presented the threats. And after that, what is lacking is how to project experts and summary in all this life cycle. In the beginning, we understand it's okay, we have two solutions. But after that, what is lacking to your presentation at the end is, now that we have understood the threat management life cycle, what is the threats, what we'll do, now where to place, what is the role of X-Force in all this cycle or of the summary. So this is, I think, the lacking slide, one or two slides, just to make as a perimeter the X-Force will fix or will work on these features, summary will work on these other features. This is what is lacking when I follow your reasoning and the way you present things. Now I have some questions related to the presentation for all of you, so who can answer. So now that you have presented X-Force and summary, how the cloud benefit, how to present this in the cloud. Does this solution are designed for cloud platforms or solution or applications, or are these based on the cloud? So how we can fit our course, our general course, which is cloud computing, with X-Force and summary? This is my first question. You have heard me?
Yes.
Why I gave you this presentation in the cloud course? Why I didn't present it in the security course? So, what is the relationship between cloud and summary and X-Force? Normally, they will provide a service to the cloud and they will benefit from cloud. So what is this relationship? What they will provide and what they will get from the cloud?
I think the purpose of X-Force is to protect the workload in the cloud. It's based on the cloud. It's not like outside of the cloud.
I'm waiting for other response. You should be able to answer that. Are there some specific threats that are related to the cloud that X-Force and summary will present, or will discover, will treat, will prevent?
I think that their main role is to treat, not prevent.
But in
like
the use case, but in the use case, you said that you have prevention.
but it's more of a treatment than prevention. Because if it were the people who used them, they already had problems and they needed to.
Which problem? If you can summarize, I know that you have presented it in the presentation, but which problems? Just now by mind.
Yeah, well, for the large bank, they had they didn't have like an automated program to pinpoint the vulnerabilities that they can fix them. I think that X-Force enabled them to minimize the time they spend to look for those vulnerabilities and to track down the owners of vulnerabilities. Like they didn't prevent the vulnerabilities, but they help them to extract them, and the vulnerabilities are always going to be there.
Yes.
For team, it's like the same problem for the team Cairo, because the MERS initiative already had problems with their routers, and with the intervention of the team, they're going to decrease the problems, but not 100% get rid of them. And in the future, it's not like they're not gonna have those problems again.
So you said that you will, if I understand you, so you said that you will discover, you will make adjust, you will that's scanning or making a test penetration to say what are the different vulnerabilities. Here are the set of vulnerabilities of our use systems. If, for example, I'm a client of X-Force, I will look for this solution to find the vulnerabilities of my system. That's what I'm saying.
I'm sorry, I didn't hear the last part. The company would.
So if I'm a client of X-Force or a Cairo, what I will look for when I go to buy this solution. So what will enable me to do? To discover my vulnerabilities, and then I will call my IT team to correct it.
No, they will help you correct it, and they will help you pinpoint it, and they will help you decrease it as much as possible.
So they will give me a corrective measures, because there are different phases. Even when you have presented the life cycle at the end, you said that you will discover the vulnerability. You said the reconnaissance phase. The reconnaissance phase, so you will discover which are the vulnerabilities that are present in my system. And this first they will give me also corrective measures, what I should do to correct these vulnerabilities. Because here, just for those who to separate the meaning of things, we have a vulnerability. So you have, for example, your system has does not have a firewall installed on your computer. So there a difference between identifying that, hey, your PC is lacking a firewall. You are not controlling the traffic that is entering or going in or outside your computer. And the second thing, that if you would like to correct, you should do so. So if you are saying that X-Force will say that, hey, here are your vulnerabilities, and here are the measures that you should do to correct it. That's it.
Yeah, exactly. And if the company is on board, they can move on to the correction part. They don't just give you the solution. They help you overcome the problem.
I don't think that it will, how it will help you to overcome the problem. Because you said it's an IBM product. So does IBM will provide firewalls? Does IBM will provide, I don't know, any other security solution or mechanism? What about Cairo? What is the difference between them? It's difficult to make people understand something that we are not understanding.
I honestly didn't understand the point of your question.
You didn't understand my question?
Yeah.
Until this level or this point, I did not see the difference between experts and Kimry. What does experts and Kimry do not? What Kimry does and experts does not? What is the difference between the two services?
I think this answers the first question that you asked about the use of cloud in this particular
No.
part and the difference. No, I'm just going to complete my point. It's that the Xverse has an interesting thing that it provides a collaborative way of managing and addressing the risks, thanks to the cloud, because it provides a way to collaborate between the service providers and the the people who are working on this risk. And I think that's the advantage that it has in terms of addressing this kind of vulnerabilities, since it enables the users to collaborate with peers to take action.
Still مازال فلو يعني. So. Okay, donc I think that it's not for the other colleagues. Have you any other questions related to it? You talked about. I have a lot of questions because the topic that you have created is very important. You talked about artificial intelligence. How does this solution use artificial intelligence? You talked even about the profile that you are interested in, the analyst, how you will how analyst can intervene in this with this solution. ما أنا حكيتوا على حاجات important على الآخر حتى البروفيل نتاعكم مش حتى but I don't see that you are
Honestly, there isn't enough information when we Googled the topic. That's all we found. That's all we were able to understand.
No, it's not the information that lacking the question. You haven't asked the right question. انتوا بين بعضكم ما سالتوش الاسئله خاطر انت حتى الاسئله هذوما فكرتوا فيهم توكي قلتهم معناها ما تسالتوش وحدكم. That's the difference. But you haven't even in mind this question to look for.
Well, you're more advanced than us, so it's normal that you think of them.
هذوما اسئله بديهيه يعني انا ما بالحق انا حبيتكم خير كان خدمتوا على لي بوين هذوما جوست فسروا لي. انا عطيتك سوليوشن تخدم على الكلاود وسيكوريتي. شنو علاقتها بالكلاود؟ شنو الفرق بيناتهم؟ واعطيني كذا هذا كيفاش نسالك على الانتليجنس ارتفيسيال. نورمالمون حتى الانتليجنس ارتفيسيال قريته دونك معناها عندكم فكره عليه باهي. اما على الاقل لي دو كيستيون الاولين تنجم فوزيت يعني نورمالمون ذاك البوت نتاع البريزونطاسيون. اوكي. So if there is no other questions, we can go to the next presentation. The other classmates, have you any other questions?
No.
So we can go to Noor for and colleagues, Ghofran and Amin for the Azure presentation.
Okay.
Are you ready?
Yes, Amin, can you share?
Yes. Yeah, sure.
لا الصوت ما يوصلش ما نعرفش.
Does it appear on the screen?
No, not yet.
we should.
Then just share the presentation.
Does it appear now?
No. ظهرت شوية بعد ما حاطة يعني. لا لا.
It's a connection problem or just try. خرجت.
No. Yes.
No. Hello?
Yes,
Yes, we are
you can
hearing
start.
you. You can start. Ami.
Okay, let's start. Right. Huh?
Yes, you can start, Ami.
Yeah, I hear voice a little bit later than expected, so that's why I can't really start
Oh.
until I fix my connection. Just give me 1 second. Is it better now?
Yes.
All right. So hello everyone. Today we're going to talk about Bluemix, FiWare, and Microsoft Azure. I and my teammates are going to present to you these topics, and hopefully you can get the most out of them. So what are we gonna talk about exactly? First of all, we're gonna tackle the basic concepts of IBM Bluemix, FiWare, and Microsoft Azure, the building blocks of the cross-platform infrastructures, of course, an introduction to the Internet of Things, and we're going through architectural differences of Bluemix and FiWare, and finally, we're gonna present to you use cases that can help you better understand the concepts. So first of all, what is Microsoft Azure? Azure is commonly referred as a cloud computing service created by Microsoft for building, testing, and deploying and managing applications and services through Microsoft managed data centers. It provides software as a service, platform as a service, and infrastructure as a service, and supports many different programming languages and tools, and of course frameworks, including both Microsoft specific and third-party softwares and systems. One of the common problems with using ARM is its complexity. It is not really easy to claim that to have really mastered the art of developing resources in Azure with ARM. Here comes the solution of Azure building blocks. So the question is, what is Azure building blocks? Azure Building Blocks is a command line tool accompanied by a set of ARM templates that is designed to simplify the process of Azure resource management deployments for those who lack the skills for full ARM deployments. What are the reasons behind Azure Building Blocks? Well, Azure Resource Manager are very powerful and allow you to deploy very large complex architectures to Azure. They acquire a great deal to knowledge about Azure Resource Manager and the resources themselves. This eventually leads to difficulty in maintaining your template because any modification can lead to unforeseen issues. Now the question is the following question is, how does it exactly works? Actually, the Azure Building Blocks project solves this problem by providing a command line tool and a set of Azure Resource Manager templates designed to simplify deployment of Azure resources. You specify settings for Azure resources using the building blocks JSON schema, and the command line tool merges these settings with best practices defaults to produce a set of parameter files. The command line tool deploys these parameter files using a set of pre-built Azure Resource Manager templates. And even though it is going to take some investment of time on the user's part to learn, Using Azure building blocks is considerably less complex than using ARM directly. In other words, Azure building blocks still use the same resource templates that you'd see for ARM deployments, and those are complicated to figure out. The difference with Azure blocks is that deployment process itself is much simpler. There are Azure building blocks templates in place to assist with the deployment of the following resources. We're talking about virtual networks, including gateways and connections. We're talking about virtual machines, like route table and extensions, and of course, network security groups. Now we move to FiWare, and I leave the word to my colleague.
Okay, hello everyone. I'm Noor Misawi. I'll present for you the FiWare basic concept. So FiWare is a created framework of open source platform components which can be assembled together and with the other third-party platform components to accelerate the development of a smart solution. The main and only mandatory components of any powered by FiWare platform or solution is the FiWare Context Broker Generic Enabler, bringing a cornerstone function in many smart solutions. The need to manage context information enabling to perform updates and bringing access to context. FiWare Next Generation Service Interface is the API exported by FiWare Context Broker, used for integration of platform components within a powered by FiWare platform and by application to update or consume context information. Next, next slide, please. Moving to the FiWare features, it's a sample providing any initiative interface readily accessible to any web developer. It's a powerful supporting subscription, notification, queries, and so support of linked data, and it's open standards. Current FiWare Next Generation Service Interface specifications are public and royalty free, and they will align with the published NSTSE Next Generation XD specification. Moving now to the architecture of the FiWare. Amy, please, next slide. Amy, next slide, please. Okay, so the architecture of the FiWare, a context broker generic enabler, which is the core and mandatory component of any powered FiWare platform or solution. It enables to manage the context information in highly decentralized and large-scale manner, interfacing with the Internet of Things, robust and third-party system for capturing updates on context for information and translating required acquisitions, context data API management publication and monetizing, bringing support to users control and the opportunity to publish and monetize part of management context data, and the processing, analysis, and visualization context information, implementing the expect smart behavior of application and or assisting end users in making smart decisions. Okay, as I finish it with the FiWare, we'll move now to the IBM Bluemix.
No,
Yes,
go back to the last slide.
the architecture.
اللي قبل هذا. Take your time to explain it. It's very important. So take your time to explain it. لا مش هذا اللي just how these layers. This one.
The architecture.
The architecture. Take your time to explain us the different layers. Are there any interaction between the layers? مش هذا الآخر. أمين ولا بدل السلايد اللي قبل.
هذا
السلايد
اللي قبله.
Okay, Miss Miss Manal, for
الاركتكتور هذا هو.
Miss Manal, for the architecture of the FiWare, I will explain it later with the IoT because we have a part of the FiWare architecture based on the IoT.
Okay.
So there is a part that
continue. Yes. Okay.
Just like the general basic concepts of architecture, but later I will explain it better. You will get a clear idea.
Okay.
Now I will talk about the IBM Bluemix. The basic concept of the IBM Bluemix is an open cloud platform that provides mobile and web developer access to IBM software for integration, security, transaction, and other key functions, as well as software from business partner. It's built on Cloud Foundry open source technology. Bluemix provides pre-built mobile backend as service capabilities, and it offers more control to application developers by using its platform as the service PaaS offerings. The goal is to simplify the delivery of application by providing services that are ready for immediate use and hosting capabilities to enable internal scale development. The next slide, moving to the features of the Bluemix. It's a range of a service that enables you to build and extend web and mobile application fast. It's fit for purpose programming models and service, manageability of service and application, and optimized and elastic workloads and continuous availability. Now I will explain for you the architecture of the IBM Bluemix, and as I said, we will later get it more with the architecture based on the IoT. So, please, the next slide. The next slide, please. Okay, at its core, Bluemix is an environment for you to build application and use service when you develop applications. Bluemix also provide an environment to host application artifacts that run on application service. By using soft layer, Bluemix deploys virtual containers that host each deployed application. In this environment, the application can use pre-built as service to make application assembly easy. As a developer, you can interact with the Bluemix infrastructure by using a browser-based user interface. You can also use a Cloud Foundry command line interface to deploy the web application. Clients which can be mobile apps application that has externally application built on Bluemix, or application developers that are using browser interact with IBM Bluemix application. Clients use the REST or HTTP APIs to route a request through Bluemix to one of the application instance of the composite service. Now we will talk about the IoT, the Internet of Things. It's something that you already heard a lot about it. Next slide. So the IoT, or the Internet of Things, is a system of interrelated computing devices, mechanical and digital machines, objects, animals, or people that are, no, the previous one, that are provided with unique identifiers and the ability to transfer data over a network without requiring a human-to-human or human-to-computer interaction. I'll explain you like the component of the architecture of the IoT. Next slide, Next slide. So for the IoT architecture, we have the sensors, are hardware components which capture information of the physical environment and transmit them to device by electrical signals. The actuators. So, okay, we have like just a cycle. The devices are hardware components integrate, connect to sensors or actuator by wire or wireless. Had the process and storage capacity to run software and establish connection to the IoTM. The driver is a software running on the device, enabling uniform access to heterogeneous sensors and actuator. Okay, so we have the later. Okay, like the sensors capture the information, transfer them to the device, and the device transfers them to the gateway, provides required technologies and mechanisms to translate between different protocols, communication technology, and payload formats. If the devices already have these protocols, then they can directly connect to the IoT integration middleware. The IoTM or IoT integration middleware is an integration layer for different kinds of sensors, actuator, devices, and application. It's responsible for receiving data from the connected device, processing it, providing it to connected application, and controlling device. Finally, we have at the top level the application with software. It's a software which uses the IoT integration middleware to gain insight into the physical environment to manipulate the physical world. So the application send back to the IoT the required action, which send it to the device, and finally the device send it to the actuator, which is a hardware component that receives commands from their connected device and translate these electrical signals into some kind of physical actions. So now I will present for you the firmware architecture based on the IoT architecture. Next slide. So the architecture and the mapping of the open source platform firmware onto IoT reference architecture. It provides an enhanced OpenStack based cloud where its capabilities and catalog is hosted. The firmware catalog contains the slide before the firmware architecture, not the IBM architecture. No, the slide before this one too. Okay, so
نور عندي مشكله في الكونيكسيون كي نبدلها تبدل مؤخر راك علاش من بكري تجي مؤخر.
Okay, so I will as I told you that I will present for you the firmware architecture and the mapping of the open source platform firmware onto our IoT reference architecture. It provides enhanced based OpenStack platform, OpenStack based cloud where its capabilities and catalog is hosted. The firmware catalog contains generic enablers representing a rich library of components. Firmware only distinguishes between devices and next generation service interface devices. Devices can communicate directly with the IoT backend or via gateway, which is positioned within the IoT edge. Both the IoT gateway and the IoT next generation service interface gateway enable and manage the communication of service with the IoT backend. The IoT backend and the data context broker provide the main functionalities of firmware, and therefore they are encapsulated by our IoT integration middleware. Application components is on the top of the data context broker. So did you get what you want, Miss?
I appreciate it. Yes, I appreciate the diagrams and the data flow that you are presenting. Yes.
Okay, so moving now to the IBM Watson IoT platform. Please, the next slide. Okay, I will present you the architecture and the mapping of the IBM Watson IoT platform. The Connect component takes care of the connection of devices to the platform. It's also responsible for a corresponding message translation. So it's encompassed by our gateway component. As it provides further event handling functionalities, it is covered by our IoT integration middleware, the analytics, risk management, and information management components provide the core functionality of the platform. So they are also covered by the IoT integration middleware. The premix OpenStar Dart-based service components and the flexible deployment components built on the basis of the platform, the IoT industry solutions, and the third-party apps components are encompassed by our application components, since they enable the connection of further application. So I will finish with the comparison of between the IBM Watson IoT platform and the firmware IoT platform. And then my friend Gofran will move to the use case. So please, next slide. No, the slide before. I mean, the slide before, like, voila, the IT platform comparison. So the devices for the fireware, we have the devices on the next generation service interface devices. However, the platform are just external devices. For the gateway, for the fireware, we have the IoT Edge. However, for the IBM Watson, it's the Connect. For the IoT IAM, we have the IoT backend plus data context broker. For the IBM, we have the analytics, risk management, Connect, information management, Bluemix, open database service, and flexible deployment. The application is for the fireware is just external. And for the IBM, it's IoT industry solution plus third parties. So as I finish it, my friend Ghofran will present for you the use cases. Ghofran.
Hello, everyone. So we have 2 use cases for fireware and 1 use case for Bluemix. Let's start with Stop By use case. So Stop By is smart parking solution favoring rapid rotation of vehicles. 30% of traffic congestion is due to parking surge in Belgium. Stop By reduces parking surge while simulating local commerce. That's from where comes the name Stop By. Stop and Buy, it means. It offers short duration parking, nearly commercial areas. Parking spots in each zone are equipped with on-street and off-street sensors, like in the pictures, detecting the presence of cars and recording their parking duration. The mobile app Stop By advises drivers where is the nearest spot available to parking for a certain duration. The timer on the app notifies the driver on the time remaining. Besides, market managers receive statistics on usage patterns per parking spot and per parking area and comparative analysis between periods. So Stop By makes use of several fireware generic enablers like Orion Context Broker, RESTful API, and Proxy and Docker. These generic enablers make it possible to capture updates on context information from the sensors and transfer them to the system. Now, the second use case, which is called the Cardio ID, it is a machine learning-based driver assistance system preventing accidents.
Sorry, I mean next slide.
It's the first, yeah, it's the second one. Okay.
سيبون تعديت راهو انت تعديتي ساعات تبطأ عندكم راهو انا معناتها نبدلها وتبطأ باش تتبدل ما عرفتش تبدلت ولا
بدلت. So Cardio ID analyzes the electrodiogram of the driver's hands to detect the cardiac health situation of the driver and detect any drowsiness and fatigue that might affect the safety of the driver as well as the fleet. The cardiac signal is acquired from a custom steering wheel cover that is equipped with special conductive sensors responsible for capturing the electrical impulses generated by the heart of the driver. So it is a kind of small sensors on the hand of the driver. So drowsiness, fatigue, and heart problems are detected by machine learning algorithms in order to immediately alert the driver. So how is this implemented with fireware? So the context broker stores current positional information of the vehicles, whether buses or cars or whatever, with their location, speed, and altitude, and more measures, as well as the driver's well-being metrics, such as heart rate and drowsiness. Additionally, the context broker is configured to notify the CNUS service, which is in turn persists the contextual information into Hadoop distributed file system. This file system is also used to store the recordings obtained from the SD card, the signals from the heart beating, and etc. So the API itself is implemented in Python using Falcon Web framework. This API was designed also taking into account the integration with the third-party sensors, namely fleet management systems, that will consume the information provided by our system. The last case is
next slide.
So the last case is Deloitte healthcare interactive platform. It's a Bluemix use case. So to address the growing cost and complexity involved in maintaining and updating platform of state healthcare programs, Deloitte teamed with IBM to create the MES Health Interactive Platform, an offering designed to tie Medicaid IT modules together in a flexible cloud-based architecture. So Van Spalding, who is a senior solution architect for Deloitte Consulting, said Deloitte wanted a hybrid hosting model where it could offer a software as a service solution to its client, but still maintain single tenant architecture that wouldn't mix client data. So the MES solution is based on IBM's VMware Cloud Foundation that provides firewall services, virtual SAN components, and other virtual resources for rapid deployment. He said VMware Cloud Foundation allows us to quickly and dynamically adapt, but also have layered security controls we need. VMware Cloud Foundation is the hybrid cloud platform for maintaining VMs and orchestrating containers built on full stack hyper-converged infrastructure technology. So that's it. Thank you for your attention, and if there are any questions.
Thank you very much. So I think that's I appreciate a lot the presentation. I like the fact that you go deep in the different topics, and this is a general remark for all your friends. When you go deeper, I'm happier. So just I have a question related. So you started with Azure and Microsoft. Then we forgot it after that. What even if the use case, you said that now the framework is
when you mentioned in the description of the topic, you said use case of IBM and FireWare and the comparison between IBM and FireWare. So we
مدام en fait كي تشكيناها في الديسكريبسيون ما فهمش ازور في معناتها من بعد في الكومباريزن وفي اليوز كيس علاش ما خدناش.
So we present them as like a cloud environment where you can develop your application, and we get more into with the FireWare and the IBM. That's what we get from the description of the project.
Just by curiosity. معناتها بالكيوريوزيتي تو كي تجاوبني وانت شفتهم الكل. اسكو اجور وين نجم نحط
Azure, it's like, as we studied, Azure, it's like cloud-based foundry where you can develop your application and host them.
Donc, if he will interact with FireWare and Bluemix, it would be defined at which level?
In the application level.
Oh, exactly. You said that FireWare is
FireWare is basically oriented for IoT stuff. IBM Bluemix is like an open source environment where you can develop your application. Same for the Azure. It's like a cloud environment where you can develop and host your application.
And FireWare can interact with Azure also?
I'm not sure. I will just Makes
So here firewall, just to make it to summarize, so firewall is a broker. So this broker will interact with different cloud service. From these cloud service providers, we find Bluemix, we can find Azure, we can find
So,
Amazon.
yes, it can interact with Azure.
Yes, just from Azure, is there modules or packages that you have presented related to the IoT, to the Internet of Things?
I didn't really make researches. As I said, that we presented the basic idea of the Azure, but just a few minutes and
ميساج نو جوست سون دي كيستيون. الخدمه نتاعكم باهيه بالكدا، دونك عجبتني بالكدا. زي سيت انا البوت نتاعي بارتي اناليتيك، هذاك ديجا اللي نطلبوا من لي جروب الكل انك تبوز لي معناها لي كيستيون، تو تبوز دي كيستيون من انت كنت تدخل في ما تقعدش جوست نقرا الديسكريبسيون باش نلقى على سيت ويب، نكون تحفه. This is my goal، معناها هذاك الهدف نتاعي في الوحده.
Thank you.
ايه ميرسي، ان شاء الله لاباس نور.
ميرسي.
ويكند.
هاني شادة الدار وربي يستر، دي زوجين الصغار بتاع هواية وفزاء، تيب هاني شادة الدار وربي يستر.
ان شاء الله لاباس والله لاباس.
Thank you.
Now we go to the third group. كان فما أسئلة أخرين الساعة قبل ما نتعدى.
مدام جوست كان نجم نقول لك حاجة، أنا عندي مدة معناها حكينا على البي اف او ومازلت ما خديتش ريبونس من عندك. غفران.
It's okay from my side.
حتى أنا زدت ما حكيتش معاك ومش نحكي معاك.
خلينا نكملوا السيونس من بعديك. هذاك ديجا باش نطلب منكم الكل، انا سورتو البون البي اي بالطبيعه مرحبا بكم، سورتو على السينيور اي تي يعطيوني تو ليتا اللي لقى سوجي اللي ما لقاش ولا ليتا دافونسمون، دونك تبعثوا لي بالله من هنا الماكسيموم غدوه الصباح.
مادام انا
وي غفران سي بون، انا نتذكر خاطر بالحق ما رجعتلكش اما سي بون معناها السوجي نتاعي.
مادام جوست ماذا بيا كان معناها تتذكر معناها السوجي، ماذا بيا كانت تنصحني شويه الحاجات اللي في الاي تي وفي البارتي ديبلومون والاخرين، خاطر ماذا بيا من توا نحضر فيها، دونك كيف نجم نقرا بالضبط اسكو نستحق باش نكتب ولا اي بي ايز.
اوكي تم من هنا العشيه نرجع الميل نتاعك نثبت بالضبط، خاطر نتذكر وقتها عجبني مش مع السوجيك باهي، اما نرجع للميل ونجاوبك عليه باللي قلت.
مدام ميرسي.
دونك بالنسبه كيما قلت لكم سينيور اي تي، هنا الغدوه ماكس تبعثوا لي ليتا دافونسمون اللي لقى في السوجي اذا كان مع اونتربريز اللي
معلش انا عملت انتروتيا مع اورانج في الديفلوبمون موبيل ونورمالمون سافا، معناه عملت انتروتيا تكنيك وعلى اساس جمع هذه الانتروتيا ثاني نورمالمون سافا، اما في سيكتور ديفلوبمون موبيل ما معطونيش السوجي ديتايي.
هذاك انا بعثت كيما اللي قلتوا لي، هذا بعثوا لي باغ ميل.
اوكي ثانك يو.
وقل اصحابك الكل اللي مش حاضرين بالله يوصل لهم انت اكثر، انت وسيرين حاولوا توصلوا لاصحابكم.
اوكي
ولا دونك علاش سالتني كيفاش ديجا في الشات كل واحد كيفاش قاعد يقدم، دونك ديجا فدوى قال جواب يعني ريدي، دونك الجروب من بعديك الجروب نتاع الهام تاع دينا قاعد علاء، دونك توا فدوى اذا كان مازلت دونك موجوده دونك
انت باخي مدام.
Hello. Hello.
Hello. And you can share your screen and you can start.
Yes. Can you see? Can you see?
Yes.
Okay.
So hello everyone, my team Fadwa Ben Ramadan, Akram Mahfayed and Aison Sarasas will be presenting Cloud Foundry today. We'll be talking about the general concept first. Next slide. We'll be talking about the general concept first, then we're going to present the building blocks, the relationship with GitHub, and finally an interaction with Cloud Foundry. So first, what is Cloud Foundry? Next slide, please. Okay. In fact, it is an open source cloud platform as a service governed by the Cloud Foundry Foundation that provides a choice of clouds. Since it is open source, it is made available through various private cloud distribution as well as public cloud instances. It has multiple application services such as MySQL, MongoDB to store and manage the database, which is the most popular service. It also offers other services that might include logging, messaging, or other tools common to multiple applications. Cloud Foundry provides a wide range of developer frameworks like Spring for Java, Rails for Ruby to clients. Next slide. It is a service on which developers can build, deploy, run, and scale applications. Cloud Foundry is promoted for continuous delivery as it supports the full application development cycle from initial development through all testing stages to deployment. This multi-cloud environment allows developers to use the cloud platform that suits specific application workloads and move those workloads as necessary within minutes with no changes to their application. Cloud platforms enables anyone and everyone to deploy a network application or service and make them available to the world within minutes. When an application becomes popular, the cloud scales it up to handle more traffic. However, not all cloud platforms are created equal. Some have limitation in terms of language and framework support, while others lack key application services or restrict deployment to a single cloud. Therefore, Cloud Foundry has become the industry standard. Next slide. Next slide. Okay. So, as the main characteristics, can you see the next slide? Right. Okay.
Yes, the characteristics.
Yes. So, as the main characteristics, we have extensible architecture to digest future cloud innovation. In other words, Cloud Foundry was not only built to support popular framework of today, it is also easy to add new frameworks. Contribution by many companies, updates, and new features are faster. It is also language independent. Cloud Foundry's container-based architecture runs apps in any programming language. Choose any language runtime and add a new language as needed, including Java, PHP, Python, and Ruby, etc. It also offers admin separation. Administration and developers can work in parallel. We also have the standard command line interface, which is the same used by all Cloud Foundry providers. Then we have fast application development and deployment. You just create your application and deploy it. No worries about deployment management. Then we have highly scalable and available architecture. Developers don't have to provision the infrastructure, but get an environment where they can develop and scale their application in a flexible manner. It is basically open source code, as we said. The platform's openness and extensibility prevent its user from being locked into a single framework, set of app service, or cloud. And finally, we have the flexible infrastructure. You can deploy Cloud Foundry to run your apps on your own computing infrastructure or deploy on NIS like Azure or OpenStack, etc. All of these contributes to reducing the chance of a human error. There are many Cloud Foundry providers like, next slide, like Atos, Cloud, Swisscom, SAP, etc. Next slide. When talking about Cloud Foundry, it is necessary to talk about build packs. So what is a build pack? Actually, it defines a container for running an application. For example, one build pack might run a Java web application, another runs a Node Java application. Cloud Foundry offers a number of standard build packs. Build packs provide frameworks and run support for apps. They typically examine your apps to determine what dependency to the node and how to configure the apps to communicate with bound service. When you push an app, Cloud Foundry automatically detects an appropriate build pack for it. This build pack is used to compile or prepare your app for launch. Next slide, please. Cloud Foundry has an architectural structure that includes component and a high level of exchange and usability of information to permit integration with development tools, application deployment, application lifestyle management, integration with various cloud providers, and finally, application execution.
Okay, can you hear me?
Yes.
Okay, so now for more details, now we move to the building blocks of Cloud Foundry, where we will explore in greater depth the components you'll need to build an entire Cloud Foundry architecture. Cloud Foundry is abstracted as a set of large-scale distributed services. We have the routing, the authentication, the app lifecycle, which include the cloud controller and the health manager, and the app storage and execution, which include the DEA, and we have the messaging and the services. For more details about the components and the interaction between them, we have the routing. So the routing routes all external system traffic and application traffic from the internet or intranet. Once an application is deployed in Cloud Foundry, all external system and application traffic is controlled and directed through the router. The router maintains a dynamic route table for all applications deployed in a load balanced environment. So you don't need to worry about updating routing information to reflect change to a deployed application or the underlying DE8, which we will discuss soon. You can also configure routers for high availability, refining the number of routers you require to support a load balanced Cloud Foundry environment. And then after the routing, we go to the authentication, which include the UAA and login service. UAA, User Authorization and Authentication, provides identity, security, and authorization service. UAA is an Auth2 token issuing service that allows authentication on behalf of the resource owners between client application and authorization service. What's an Auth? An Auth is an open standard for access delegation commonly used as a way for internet users to grant website or application access to their information on other websites, but without giving them the password. After we get the authentication, now it's the cloud. We have now the cloud controller. The cloud controller reacts as the brain of the Cloud Foundry environment. The cloud controller maintains command and control system, including interface with clients, run apps and other processes on the cloud's virtual machine, balancing demand and managing app lifecycle. The cloud controller in Cloud Foundry provides REST API endpoints for client to access the system. The cloud controller maintains a database with tables for orgs, space, user roles, and more. As soon as the user requests an application deployment via the command line interface, the first request goes to the cloud controller. It's then the controller responsibility to redirect the request to the correct DEA available on the pool. In the app lifecycle, we have the health manager. The health manager monitors application uptime by listening to the NATS messaging. Before, for mismatch application states, the cloud controller publish expected states to the DEA DEA's publish actual state. State mismatch are reported to cloud controller. For example, if an instance fails to work or number of instances is more than scaled number. Now for the app storage and execution, we have the DEA, which is droplet execution agents, are secure and fully isolated container. A DEA is the core of Cloud Foundry functionality, some of the tools that help DEA achieve its goals, which is build packs. Build packs are smart enough to identify the programming language, framework, and application container you'll need to properly deploy, and then automatically download everything for you from GitHub. We have the Droplet. The Droplet is the Cloud Foundry unit of execution, Once an application is pushed to Cloud Foundry and deployed using a build pack, the result is a droplet. These droplets are stored in a blob store storage for further deployment process. And then we have the warden. The warden, once the droplet is ready, it will need hosting in a suitable environment. In Cloud Foundry, this is called a warden container. Now, so what's a DEA? What the DEA will do? The DEA will select the appropriate build pack and use that to both stage your application and ensure complete life cycle management. The DEA are responsible for apps lifecycle, building, starting, and stopping apps as instructed. The DEA will continually broadcast the application instance health status to the health manager, which will periodically broadcast messages about their states through the NATS messaging bus. So what's the messaging NATS? The messaging NATS is a fast internal messaging bus to manage system-wide communication via publish and subscribe mechanism. And finally, we have the service brokers. The service brokers provide an interface for native and external third-party service process run on service nodes or external as a service provider, like email, database. So the service brokers can be used to define the relationship between the application and services like database. There are just a couple of things that may not be direct parts of the Cloud Foundry environment, but are worth discussing. The CLE. The command line interface is an interface to deploy and manage your application to the Cloud Foundry environment. The BOSH creates and deploys virtual machines on top of physical computing infrastructure and deploys and runs Cloud Foundry on top of this cloud. So finally, we have two architectures, just for note. We have two architectures, the DEA and Diego architecture. Actually, there's no huge difference between these two. In fact, the biggest reason is Warden Cloud only manage containers on virtual machine running Linux, but the Garden subsystem reports virtual machine running diverse operating systems.
Now we explain the relationship between GitHub and Cloud Foundry. So Cloud Foundry uses GitHub as a storage location for source code, build packs, documentations, and custom configurations. It is used by developers for their own apps and custom configurations. As for large binary files that cannot be managed by GitHub, Cloud Foundry maintains an internal or external blob store to store large binary files like droplets. The problem with GitHub is that it cannot maintain a large piece of binary files because it is designed only to store the codes. So for the large binary files, it will be handled by the cloud. Now we move to the interaction with the Cloud Foundry. Next slide. Yes. For the interaction, there are different ways to interact with Cloud Foundry. I cannot see the slides.
Actually, there's an internet problem, but I can see the slide. The interaction with Cloud Foundry. Can you see it now?
So for the interaction with Cloud Foundry, there are different ways to interact with Cloud Foundry, either through command line interface, the CLI, which we talked about, from terminal command prompt, or through IDE plugins, through vendor-specific web user interfaces, or through cloud integration tool. Now we move to the architecture of the environment of the Cloud Foundry in the next slide. Yes, so for the environment, we have the Cloud Foundry space. So every app has a Cloud Foundry space that the app is scoped to. It encompasses features such as orgs, apps, domains, security quota. There is also the Cloud Foundry organizations, which segregates tenants in the Cloud Foundry installation. Then we have quotas, which provide resource limits to orgs and spaces. And we then run the Cloud Foundry target to confirm your org and current space. And the Cloud Foundry target encompasses identification features such as API endpoints, user, org, and space. Now moving to the app lifecycle of Cloud Foundry. The next slide. Yes. So when an app is being created, it goes through several steps. First, we run a command line, a Cloud Foundry push, CF push, which is being used to create an application in Cloud Foundry. The co-CLI sends then that command to the Cloud controller and tells the Cloud controller to create an app. The Cloud controller, we talked about, it's an application runtime which is responsible for calling APIs. It will store then that application which you have provided at that time of running the command CF push. It will store all the application libraries of that code using the build packs. And then once all the application is being packaged together, Cloud Controller uploads app files and stores the package into the blob store, which is the repository of the large binary files. The controller blob store will send a request to the auctioneer, which is part of the Diego cell staging, to stage that application. And it will send a request to the executor to schedule and create an auction for the staging. The executor of this Diego cell then will create what it's called a garden, which will download the droplets from the blob store and start running it. Then the Diego will send a report back, the report of the running application to the Cloud controller, which will send that request back to the CLI. That app has been created, and then the user will be able to see it. Now we move to deployment of the Cloud Foundry with Sandos.
Okay. So we were asked to deploy an app. We are going to need two things, Cloud Foundry CLI and Cloud Foundry. First, we install the Cloud Foundry CLI according to our operating system from GitHub. Next, we can run the command prompt. And to verify if it works, we type CF. Simple guide will show stating all different commands used along with its usage. Next, we need to sign up for a Cloud Foundry, which is in our case SAP, and have a SAP trial account. As you see here, the organization name, ID, and the IPA endpoint. There is our space. We have 0 application deployed for now. Then we log in using the IPA endpoint and use the code CF login. Then we enter the email and password. After authentication, the organization and the space will be shown. Next. Before pushing any app, we change a directory where the application is located, which is in our case a web application. After this, we run a CF push command to deploy our application. As you see here, we have the requested state, the build packs used, the number of instances, and we also have the build packs, which is Ruby, since our application is a web application. Next, you can see that in our account that the application is deployed successfully. We can deploy an application easily from here. And for our example, we have two deployed applications. To see the deployed application using the CLI, we run a CF apps command. We can access our application from any device through the URLs provided. Like here, it is the URL. So you just type it. And this is our application. It is a simple web application. We can see the build packs by just typing cf build packs command. We can also delete an already deployed app. So you just type cf delete. As you can see here, we deleted the web app. As you see in our application, the app is deleted. We only have worker app now. We can scale the application by increasing the instances to 5 through the command cf scale, for example, right here. And the result will be as following in the account. Like you see here, 5 instances. And you can just simply add instances, increasing them by here, or downgrading them by here. So you can also change the quota. And that's it. Thank you for your attention. Any question?
Very good. So, Fadwa, Saunders, and Akram, you deserve an applause. Really, it's a very good work. So
thank you.
Even your presentation could be used as a very good reference to anyone who would like to use or understand crowdfunding. So I appreciate it a lot. It's a very good presentation. I think that you have very well explained the different components of it, the interaction between the building blocks. I appreciate a lot how you go outside crowdfunding to build the whole image, to draw the whole image related to GitHub, to the CLI, how we can interact with it. And finally, the lab or the application that you have, your application that you have deployed. It's a very good presentation for me. Have you any question for the other classmates? I appreciate your work. Very good.
Thank you.
Thank you.
Have you any questions for the other classmates? Crowdfunding is really very important. You can use it to, as they said, to deploy any application from any language, and for other application that you don't have developed from by yourself. So any application you can be deployed, so could be publicly accessed by anyone from the internet, could be staged. So it's very important application or the platform that will it's open source. So you have the trial version. You can use the trial version, and they are which is paid. But the trial can help you even to deploy any application and make it accessible from the internet using any kind of language. So it's very important. You can use it in the future. If there is no any other question, we can go to the next presentation with the group of Ilham Saadawi. Are you here? Are you ready?
Yes, Miss.
Yes, you can share your screen.
Can you see my screen, please?
Yes.
So, hi everyone. Today we will talk about OAuth 2 and Salem 2, two interesting methods widely used nowadays. This presentation will be performed by Ilham Saadawi and myself, Hamza Labid. Our presentation is divided into different parts. We will first talk about the basic concepts of OAuth 2 and Salem 2. Then we will walk through definition and of the building blocks of single sign-on. Then we have two different use cases about OAuth 2 and Salem 2. After that, we will talk about architecture difference between them, and finally, we have conclusion. So guys, let's start. Before jumping to the definition of OAuth 2, we created for you a video from scratch that will give you an idea about its concept. So let's watch it together.
Finally, the winter break, you have been in a lot of stress because of assignments, presentations, and exams, and it's time for relief. You decide to spend a couple of days in the hotel. When you get in the reception hall, you go to the front desk agent to give her your ID and the credit card for the registration. Of course, after checking your information and validating your booking, she will provide you with the key card to access your room. Doesn't all of this seem easy and familiar? This is what OAuth2 is all about. Change just the names, but keep the same concept. The ID card is your email, the credit card is your password, and the key card is your access token. Guys, it's very simple, so let's dive together into more details.
As you can see, we made this video a while ago before the winter break, so sorry for that. This is the main concept.
It's good, thank you. It's good.
Thanks. This is the main concept that you should keep in mind. So now let's dive into more details and see how OAuth works exactly. Sorry.
Imagine.
So OAuth2 is an open standard for access delegation, commonly used as a way for internet users to grant websites or applications access without giving them the passwords or generating access tokens. Let's discover the different steps used to generate these access tokens. In the first step, the application requests authorization to access server resources from the user. In the second step, if the user authorizes the request, the application receives an authorization grant. While in the third step, the application requests an access token from authorization server, which is the API. In the fourth step, if the application identity is authenticated, the authorization server issues an access token to the application. After that, in the fifth step, the application requests the resource from the resource server and presents the access token for authentication. And finally, if the access token is valid, the resource server sends the resource to the application. Let's try an example to see exactly how these steps are done and how our access token look like. So we developed for you a RESTful API using OAuth2. Just the backend of a website where you can register, log in, and purchase a product. I have already run our local host. We will use Postman as software to check our HTTP requests. Can you see it? Can you see the Postman software, please?
Yes.
Okay, very good. So we go to our cloud project. We click on registration. We go to the body. And here we have to fill different informations. Let's choose the name as cloud, email cloud 497 at cloud.com. The password 1234567. And the phone, let's put any number, random number. And let's send the request. So our account has been successfully created. Now let's try to log in. Here on the login page, we need to enter our email, which is cloud57 at cloud.com. And the password is 123456789. I think it's yes.
So
And
Hamza, could you explain why you have used Postman and what is Postman for your colleagues؟ أول مرة تستعملوه Postman ما نتصورش كان الناس الكل تعرفوا جست شنو علاش الغول نتاع Postman؟
yes, Postman is a software used to verify your HTTP requests when you work with the backend, when you work in the backend part, because you don't have the front end, so you can't check how your HTTP request works.
So you will interact with an application that is defined in the cloud. Here, in this case, we're interacting with your account to the cloud. So you are interacting, you are accessing a cloud through. So this is the interface or the tool that enables to interact with the cloud. So he will send him not only authentication and request to access. You can even execute some programs. You can even initiate applications, start them, give parameters to applications, stop applications. So it is a tool of interaction with an application or defined in the cloud. That's it.
Yes, but I'm not interacting with the cloud. I'm not interacting with the cloud.
Now you're interacting with cloud.com, no?
Yes, cloud project, which is stored in my computer.
Okay, so even we can have, because personally I have used it when I'm interacting with application defined in the cloud.
Yes, you can use it to interact in the cloud.
Okay.
But for the moment, I'm interacting with application that's stored in my PC.
Okay.
So let's try to log in. Let's send the request. We have successfully logged in, and this is our access token. This is the form of the access token, which is a long string, a long unique string generated to each customer that works as a safe identifier. Users will use this access token for authentication. We'll copy this. When we go to, and we will try to buy a product. Let's try to buy a product, for example, product number 24. And in the header of the request, let's send it without access token to see what's going to happen. And here our server failed to identify who sent the request because it didn't send the access token. Now let's integrate it. Let's send again. Congratulations, you bought this article. We have successfully purchased the product. So, as we have seen before, access tokens serves as the key card from the hotel example. Key card doesn't contain your personal information, but you can use it to access your room. Now, I'm going to let you with my colleague Ilham Saadawi to talk about SAML 2.
Okay, thank you, Hamza. Now we will move to the SAML 2. Next slide. So SAML 2 stands for Security Assertion Markup Language 2. Is a version of the SAML standard for exchanging authentication and authorization ID between entities and authorization ID between entities security domains. SAML 2 is an XML-based protocol that uses security tokens containing assertions to pass information about a principal, usually an end user, between a SAML authority, named the identity provider, and a SAML consumer, named the service provider. SAML 2 enables a web-based cross-domain single sign-on (SSO), which helps reduce the administrative overhead of distributing multiple authentication tokens to the user. And now we will see the architecture of the SAML software. Okay, so in this example, let's suppose here that the resource provider is the website called myphotos.com. So for a user opens their web browser and goes to myphotos.com, which stores all of their photos. Myphotos.com doesn't handle authentication itself. So in B, to authenticate the user, myphotos.com constructs a SAML authentication request, signs in, optionally encrypts it, and encodes it, after which it redirects the user web browser to the identity provider in order to authenticate. The identity provider receives the request, decodes it, decrypts it if it is necessary, and verifies the signature. In step C, With a valid authentication request, the identity provider will present the user with a login from which they can enter their username and password. And in step D, once the user has logged in, the identity provider generates a SAML token that includes identity information about the user, such as their username, email, etc. The identity provider takes the SAML token and redirects the user back to the service provider, which is here myphotos.com. So in E, myphotos.com verifies the SAML token, decrypts it if it is necessary, and extracts out identity information about the user, such as who they are and what their permission might be. And myphotos.com now logs the user into its system. At the end of the process, the user can interact with myphotos.com as a logged in user, and here the user credentials never passed through myphotos.com, only through the identity provider. So next slide. As I mentioned in the definition of the SAML tool, it uses cross-domain single sign-on. So let's discover what it is, this concept of the single sign-on. Single sign-on is authentication scheme that allows the user to log in with a single ID and a password to any of several related yet independent software systems. True single sign-on allows the user to log in once and access services without re-entering authentication factors. The next slide. So now let's get a little deeper into how single sign-on works. One thing worth noting, SAML isn't the only protocol you can use to implement single sign-on. OAuth 2 and 1 are also popular, as well as WS-Fed and OpenID Connect. The broad concepts can carry over across protocols too. So if you're integrating SSO into your app, you're a service provider. Your app is the service. So the provider that you're outsourcing identity to, like Okta or OneLogin, is called the identity provider. It's very simple until now. Where things start to get a bit more complex is when your app needs to communicate with identity providers to actually authenticate your user. So single sign-on works with the communication protocol SAML that governs these phone lines. And so this is how we can build and work with single sign-on using SAML, and it works through assertions. And we'll have a small example here. Next slide. Now in this example, as we can see, the user, in the first step, the user attempts to reach the app. Then in the application, the user he enters the email. Then in the third step, the user is sent to the identity provider. Then the user logs in via the identity provider. Then the identity provider sends a SAML authorization response. In the sixth step, the app receives a response from the identity provider, checks the response, and sends one-time or authentication code. And at the end, the application receives a profile and return profile to the user. Next slide. And this is an example of the assertions sent by the SAML. We will go now to a use case where we can apply SAML tool. So in this use case, Forward Inc. is a car rental service and ExampleAir.com is a travel agency. The customer of forwardinc.com logs in and authenticates at forwardinc.com, then clicks a link at the site to get a quote for a car rental. The customer profile at forwardinc.com includes the customer frequent flyer number for ExampleAir.com. The frequent flyer account determines a certain status level at forwardinc.com, and the status level determines which discount offers the customer receives for car rental. Forwardinc.com here want to present the appropriate discount information to its customer. However, it does not want customers to log in and authenticate at ExampleAir.com first, then having to log in again at its site. Here, the solution is the SAML tool. Next slide. In this deployment, forwarding is acting as a SAML requester. When a customer logs in at this site, the following sequence of events occur. The user logs into forwarding.com and authenticates the user. The user clicks a link to rent a car. Forwarding.com identifies and resolves the frequent flyer attribute. Then forwarding.com tries to resolve the attribute by looking up the user in the local user directory, but it cannot resolve the user attribute variable. How it sends an attribute query as a SOAP, which is Simple Object Access Protocol, as a SOAP request to the identity provider, which is here the example air.com. And the query request contains the frequent flyer attribute. Example air.com looks at its own user directory record for the user and resolves the frequent flyer attribute. And example air.com returns an assertion to a SOAP as a SOAP response to forwarding.com. And this assertion contains the requested attribute. Then the SAML requester, which is here forwarding.com, resolves the attribute and authorizes the user for the requested resource. And the user can finally finally redirected to the target resource.
Now let's see use case about single sign-on where OAuth is used. We have Facebook, for example, one of the websites that uses OAuth 2 in single sign-on. For example, if you try to create an Instagram account with your existing Facebook account, this will be done through OAuth 2. If you pay close attention to the above URL, you will find the word OAuth written. When you click on continue, Facebook will send an access token to Instagram. Instagram will send it back to receive certain information needed to create your account without giving your password. The cool thing about access tokens is that you can choose which resources to be delivered.
Now we move to the architectural difference between OAuth 2 and SAML 2. So from the steps, next slide, Hamza. From the steps we presented of building OAuth 2 and SAML 2, we can conclude that SAML has one feature that OAuth 2 lacks. The SAML token contains the user identity information because of signing in. With OAuth 2, you don't get that out of the box, and instead the resource server needs to make an additional round trip to validate the token with the authorization server. On the other hand, with OAuth 2, you can invalidate an access token on the authorization server and disable it from further access to the resource server. We move now to the conclusion.
Now let's move to the conclusion. Both SAML and OAuth have features that works for single sign-on. However, notable difference exists. SAML provides more straightforward enterprise security, while OAuth offers an enhanced mobile experience. So SAML sessions state leverage cookies that allow users to access specific resources in the cross-domain single sign-on process. OAuth leverage API calls. You can use it to provide temporary or permanent access to resources such as accounts, files, and pictures. In this way, OAuth is more suitable for access scoping and offers the best experience for mobile phones, game consoles, and Internet of Things devices.
On the other hand, SAML is suited especially for VDE implementation, which is virtual desktop infrastructure, because some application may reside off-premises. For instance, some application may exist as software as a service in the cloud. In contrast, others may exist as platform as a service in public clouds, such as Microsoft Azure. In instances where some services exist in the public cloud, you can extend your Active Directory to the cloud and allow users to launch those services using an SSO process. That's it, and thank you for your attention.
Thank you very much. So, it's a very good presentation. I'm proud of you. So you have showed a very good way to analyze, to make the us understand also, to define the different steps with the different details, to compare at the end. So it's, I think that's very clear. It's very good, and congratulations.
Thanks, Miss.
Thank you.
Have you any questions for the classmates? Are you here with us or not?
Yes,
Yes.
we are here. It was the presentation.
Are the presentations clear until now?
Yes.
Okay, so Ilham and Hamza, thank you very much for the presentation and for all the efforts that you have made on preparing it. It's very clear and it's very good.
Thank you, Miss.
Thanks very much.
So now we go to the next presentation.
مدام
Yes.
عسلام بربي احنا ما عيطتناش مدام احنا مازلنا ما بريزونتيناش زاد
نعم فانا في الشات بداو كل واحد يقول شكون حاضر دونك اللي
لا.
حاضر
مش مشكله ما قبيله في شو اسمه في البرزنتيشنز اللي سميتهم احنا مازلنا معناها دونك نستناو ونكملوا بريزونتيو حتى احنا الاخرين مش مشكله.
دونك فما علاء قيس المقياس من بعدهم هما فما كوبرنيتس دونك عوف كوبرنيتس اللي باش يقدموا الجروب ياخذ بعد انتم.
باهي واضح.
احنا من قبل ما جوست ما بعثناش في الشات هكا في بالك اللي احنا مازلنا.
اكتبوا لي ما جوست باش نبدا نعرفوا اللوغ كيما اصحابكم وي ار ريدي جاست.
اوكي.
Ale, if you are here, you can share your screen.
Yes, we are here. Just waiting for Haitham to share his screen.
Okay.
I already shared the screen, I think. I don't know if... Yes, I'm sharing the screen already.
You don't have it still.
Just 1 second. C'est bon.
Yes, yes. Can you hear me clearly? Hello?
Yes, I'm hearing you. Firas, Ale, and Haitham, yes.
Okay, so you may have learned about APIs and how they can be used to perform some tasks or retrieve any details while you hang around programmers. But exactly what are they and why they have been created? So for our main topics today, we're going to talk about the basic concepts of REST and SOAP APIs, the building blocks of web services and microservices, the architectural differences between REST and SOAP, and the use case for per technology. So, what is an API? Next slide, Haitham. So, imagine you are sitting at a table in a restaurant with a menu of choices to order from. And the menu of choices to order from the kitchen, which is the part of the system that prepares your order. What's lacking is the vital connection to communicate your order to the kitchen and bring your food back to your table. This is where the waiter or the API comes in. The waiter is the messenger who takes your request or order and tells the system in. The word API stands for Application Programmable Interface, and is a way to work together in different ways for different programs. There are several types of APIs and reasons of using them. To start with, APIs can be used to gain access to third party. In the case of the restaurant, the waiter will provide you with details about your order status without having to go to the kitchen yourself. The weather app on your phone will be a further example. Google or Apple didn't go out and position temperature sensors across the globe. No, these apps use a third-party API to retrieve weather forecasts instead. Apple, for example, uses the Weather Channels API. APIs allow information to be exchanged by different apps and services. They may also be used to conceal complexity and perform tasks aside from just assessing data. In the example of the restaurant, you don't need to know how to cook a perfect sushi roll, you only order one. The operating systems on our computer and phones will be a further example. Developers of applications do not have to think about getting about setting up a Wi-Fi link, drawing shapes on the screen to create a beautiful user interface, or talking to the different sensors such as accelerometer or GPS. No, the operating system instead provides developers with a bunch of APIs that simplify all of this. It only asks the device to make one. If an app wants to display a button on the screen, the app doesn't have to think about what device it runs on or what hardware it has the size of the phone. It makes developers more efficient because they can focus on what matters on to them. But aside from assessing data and abstracting complexity, APIs can also be used to extend functionality. For instance, an iOS application can show a widget in Notification Center. And to do that, the app notifies the system through an API that it has a widget available. And if the user adds it to the Notification Center, the system will contact the app to ask how it should display the widget. You may not realize it, but APIs are all around us. You've probably seen messages like these, your phone asking for permission to use your location or microphone. That brings us to the final use case. API can be used as gatekeepers. For instance, on mobile platforms, the system only has a handful of APIs that can be used to get your location. And because it's centralized in the system, it's really easy for iOS or Android to notify you when an app is using your location. So it's not the app that being nice and asks permission first. No, it's the system that does it for them.
Okay, so now let's understand what are web services and microservices, the difference between them, as well as their building blocks. So first of all, a microservice is a small autonomous application that performs a specific service for a larger application architecture. The service is concise and its objective is to do one thing well. It's quite common to interact with microservices via some kind of interface. If that interface is accessible via the web using HTTP, then it is a web service. Some web services are RESTful and others are not. It's worth noting that not all microservices are web services. Not all web services are RESTful, and not all RESTful web services are microservices. We are going to provide a technical overview of core architectural building blocks for successful web services and microservices architecture. Now let's take the example of Amazon Web Service, which is the world's most comprehensive and broadly adopted cloud platform, offering 175 fully featured services from data centers globally. As of 2020, AWS comprises more than 175 products and services. Most of them are not exposed directly to end users, but instead offer functionality through APIs for developers to use in their applications. Amazon Web Services offering are accessed over HTTP using REST architectural style and SOAP protocol for all the APIs. We'll discuss its core building blocks, which consist of compute, storage and databases, and network. So let's start with the first one, compute. Services actually is the provisioning of computing resources on demand. This cloud computing there involves the delivery of virtual or physical resources at a service. AWS compute offering are EC2, ECS, Lambda, and Lightsail. Let's move to the cloud storage, which is critical component of cloud computing, holding the information which are used by applications, big data analytics, data warehouses, Internet of Things, databases, and backup and archive applications, all rely on some form of data storage architecture. Cloud storage is typically more reliable, scalable, secure than the traditional one. Storage services in AWS refer to a place where users can keep content and make it available anytime. AWS offers several storage services. We will focus only on the most commonly used and popular services like Amazon S3, Amazon EBS, and Amazon Glacier. Now let's understand the next core building block, which is database. Amazon offers a broad range of databases purpose-built for specific application use cases. AWS fully manages database services including relational databases for transactional applications, non-relational databases for intermediate scale application, data warehouse for analytics, and in-memory data store for caching and real-time workloads, and the graph database for building applications with highly connected data. If you are looking to migrate your existing database to AWS, the database migration service makes it easy and cost-effective. Now, further moving to our last core building block, which is networking products. What are they? AWS networking products enable you to isolate your cloud infrastructure, scale your request handling capacity, and connect your physical network to your private virtual network. AWS networking products work together to meet the needs of your application. For example, Elastic Load Balancing work with Amazon Virtual Private Cloud to provide robust networking and security features. Among the AWS networking products, there are Amazon VPS and Amazon Route 53. Firas?
Sorry, Ali.
Sorry, Ali, yes.
So the difference between the architectural difference between REST and SOAP. SOAP stands for Simple Object Access Protocol. Access Protocol. SOAP has been around since the late 90s and enjoys all the benefits of long-term use, but not as simple as the acronym would suggest. REST stands for Representative State Transfer and is the newcomer to the block. It seeks to fix the problem with SOAP and provide a truly simple method of accessing web services. 70% of all public APIs are REST APIs. You need to select between SOAP and REST based on the programming language you use, the environment in which you use it, and the requirement of the application. SOAP is definitely the heavyweight choice for web service accesses. It provides the following advantages when compared to REST language. Platform and transport independent. REST requires the use of HTTP, works well in distributed enterprise environments. REST assumes direct point-to-point communication, is standardized, provides significant pre-built extensibility in the form of WS, standard built-in error handling and automation when used with certain language products. REST is easier to use for the most part and is more flexible and has the following advantage when compared to SOAP. No expensive tools required to interact with the web service, smaller learning curve. It is efficient. SOAP use XML for all messages, while REST can use smaller message formats. It's fast, no extensive processing required, and closer to other technologies in design philosophy.
There are a lot of technologies that can make this communication possible, such as RMI, Remote Method Invocation, Kerba, or DCOM. But when it comes to security or compatibility, these technologies seem to cause a lot of troubles. Instead, the modern technology is generally based on two new models, which are SOAP and REST. Both SOAP and REST are based on service-oriented architecture. Their development process includes something called Web API, which represents the interface for consuming their service. Various applications such as conferencing, web or social applications can be developed using these web services because there is not required any prior knowledge before usage, what makes them platform independent and loosely coupled. There has been created a sample web service aiming to illustrate the whole concept. Next, please, Ivan. This service is done by following the REST principles. The service creates a to-do list, which can provide all of the to-dos or give you details about a particular item in the list. The service is done by using Flask, which is a lightweight Python framework but it can be done in any other language that supports web. Next, please. The snippet represents the sample data that will be used to demonstrate the service. The very first method to be treated is getTasks, which as a result returns the list of all tasks. In REST terms, it's a get method. Following are represent the code and the execution of the same. This is then the second picture represents the response for getTasks method. Next, please. If the user needs only a particular item of the list, REST principles provide a simple solution for that. Instead of getting all items and then cycling the whole array to find the particular item, REST service offer the item to be accessed directly. GetTask ID is such a method, which ID represents the ID of the item the user needs. The second picture represents the response for this method, getTask. Other features like adding items to the list or deleting items from the list work in pretty much the same way. To put a new item, the same URL as getTasks is used, but instead, the method is set to post and a JSON formatted document containing task details is required as a parameter. To delete an existing item from the list requires delete method type and specifying the ID of the task to delete. Next, please. Now we'll discuss an already deployed SOAP use case. We all know that most recent web services follow the stateless standard, meaning that clients don't care about the state of operations between different calls to the server. However, situations that involve multiple chained operations still require stateful operations to make the whole transaction act as one. Some cases require replicating transactions and even performing a rollback if needed. Since SOAP supports stateful operations, bank transfers use this protocol because they usually require communication between multiple banks or branches involving many calls to various web servers. This process is made easier with the coordinator to keep track of their status. The banking industry typically groups all these operations into transactions. And finally, these are our references. Thank you for your attention, and we are pleased to hear your feedback. Thank you.
Thank you for the presentation. I have so the succession of the methodology was good. Just one thing I have when you talked about the Azure and Microsoft and iOS services, you have used this example to show the providers that are using SOAP and REST. What was the purpose of introducing them? When you tried to explain the difference between service, microservice, and web service. So after that, you gave the example of Azure. So it was for which purpose? Just to say that these are the services that Azure is offering in this for this type. Hello. Hello, are you hearing me?
Yes, we are.
Yes, we hear you.
Yeah, it's just the part that Firas has looked for, so just waiting for him if he's available to answer your question. Firas.
Waiting for Firas, I have another question related to the last example when you in use case of the SOAP. You presented a use case and you said that it's good for the banks, but you didn't mention how they work with it.
Actually, bank use this protocol because they usually require communication between multiple banks or branches involving many calls to various web services. That's why they use it, actually. So this process is made easier with the coordinator to keep track of their status.
And for the cloud now, because when we have presented the REST and SOAP, we said that they are from the technologies or from the protocols that have enabled to define the cloud computing. So how SOAP will solve for the cloud?
I didn't hear the question.
So I said that you said that for SOAP is good for the banking use case because they enable different branches to interact together. And I asked you, what about the cloud now for the cloud application? Why they need SOAP? What SOAP can provide for cloud applications? Especially that we have said that SOAP and REST are from the building blocks of cloud computing.
Oh, okay. I got the question. Just little something. Firas is waiting. I guess.
Yes,
you
I
went out.
accept.
Oh, okay, okay.
Which question we will answer?
I think that the fact that how REST and SOAP can be benefits with the cloud is that the fact sending and receiving information using APIs from the cloud to your application using REST and SOAP can make it easier and faster to send and receive informations on the cloud. So not just information using the APIs on the cloud.
It was clear that for REST, you said that especially in the use case example, the to-do list. So you have a service that will or you have an application is providing a special function, so it is doing a function, and you are developing a new application. So this application will just ask or get the results of what the first application is doing. So which is only ask it, and as the result would be used by the second application. So you don't need to develop another time a second application. This is clear for the REST example. Now, what about the SOAP? Especially that I like the slide where you have presented the service, web service, microservice, and SOAP and REST. Can you go to this slide? Yes, this one. So here, what is the difference between, now as a conclusion, if you would like to summarize your presentation, what would be the difference between the SOAP web service and the REST web service? When I will use the SOAP and when I will use the REST? Hello? Hello? هيثم عليه فراس
Firas, are you here?
باهي حتى فيكم انتم علاء ولا هيثم تو مع الكيستيون ريلاتيف للبريزونطاسيون الكل مش بالضروره هنا بالذات. So you said that SOAP and REST are web services. They are enabled and they interact with the microservice. It's clear. But what is the difference when I will use SOAP, when I will use REST? What SOAP enable me to do and REST will not enable me to do. شنو الحاجة اللي واحد يعطيها لي والآخر ما يعطيها لي؟
So REST works better with well-distributed enterprise environments because it assumes direct point-to-point communication. And also REST is standardized, so it works better in those kind of environments. Also, REST provides built-in error handling and automation, but SOAP doesn't.
Okay, so but both of them are used in the cloud.
So it depends because if you're like, for example, beginner, REST is easier to use and it is more flexible. Also, it doesn't necessary any expensive tools to interact with web services. But if you're using something bigger or more complicated, that's when SOAP comes into hand better.
So when I'm sending or calling application using SOAP, I can give more parameters. I can go more fine. معناتها نجم نمشي ندخل plus en détail بالسوب أكثر من rest.
Not on detail. Our REST is more flexible. But SOAP,
حسيتكم vous maîtrisez من SOAP. حسيتكم vous maîtrisez معناها فهمتوا أكثر REST من SOAP.
Yeah, because the REST is more the more used. REST is more used, and so even documentations is more available about REST than SOAP. And even when we decide to use one of them, we're gonna go with REST. I mean, even if when I asked the people, all of them use REST, so that's why maybe have more information about REST than SOAP.
Why they're using more REST? علاش يستعملوا فيه؟ عنده فانكشناليتي في حاجة أكثر من السوق. No.
What I noticed is because it's easier to use and it is more flexible than SOAP.
ومادام في راس معاك في راس مناه.
Apparently, he's having internet connection problems. Apparently.
The other question related to the next slide of the Azure still بالنسبة لي الكيستيون اللي بعدها اللي سألتكم على السلايد اللي من بعده. شنو العلاقة بتاعه شنو بالضبط؟ What you'd like to show with this example? It's not clear for me until now. As this one. Okay, so we can go to the next presentation. And here we'll have Kubernetes and OpenShift.
مدام بعد كوبرنيتس عنا مدام
في الشات موجودين انتم تشوفوا بعضكم. دونك فما اريج
احنا ستريم بوكس اند روزا وبعديك انتم برانسيب
وائل وامين وكذا.
اوكي مدام.
Can you see my screen?
Yes, we can.
Yes.
Hello everyone. My team and I are going to present Kubernetes and OpenShift. The content of this presentation, Kubernetes concept and architecture, OpenShift concept and architecture, the differences between Kubernetes and OpenShift, Kubernetes use case and an OpenShift use case. So let's start. What is Kubernetes? Kubernetes is an open source platform for deploying and managing containers. It provides a container runtime, a container orchestration, container-centric infrastructure orchestration, self-healing mechanism, self-discovery, and load balancing. It's used for the deployment, scaling, management, and composition of application containers across clusters of hosts. But Kubernetes is more than just a container orchestrator. It could be thought as the operating system for cloud-native applications in the sense that it's the platform that applications run on, just as desktop applications run on macOS, Windows, or Linux. It aims to reduce the burden of orchestration and relying compute, network, and storage infrastructure and enable application operators and developers to focus entirely on container-centric workflows for self-service operation. It allows developers to build customized workflows and higher-level automation to deploy and manage applications composed of multiple containers. Building blocks. A Kubernetes cluster consists of two main components: the control plane or master, the worker nodes. The control plane has the following components. These components are responsible for maintaining the states of the cluster: the etcd, the API server, the scheduler, and the controller manager.
Just the moment here, I will intervene. So here, Kubernetes for all the other classmates. Here, Kubernetes will enable the orchestration of different containers. So here she has different containers, and we will have a Kubernetes master, what is called master, that will enable to manage, to initiate, to make the load balancing. So it will orchestrate or define different, manage different containers to enable the provision of the service. So this is just to make it clear. It's important to try to follow your colleague.
Okay. Every worker node consists of the following components: kubelet and the container runtime, Docker. These components are responsible for deploying and running the application containers. I will leave you with Marlene to further explain the master.
So we'll start by explaining the different components of the master. First of all, we have the etcd. Kubernetes uses etcd for storing the cluster status and metadata, which includes creation of any objects, such as pods and deployment. etcd is a distributed key value store that provides a reliable way of storing data across a cluster or machines. As mentioned in the diagram, IPE server is the only entry point that can directly talk to the etcd stores. Any other control plane component will go through IPE server only. Kubernetes stores all its data and the registry directly in etcd. Next, we have the IPE server. Can you please go to the next slide? Thank you. Kubernetes IPE servers is the central place that for all other components. IPE server will take care of validating the object before saving the information to etcd. The client of the IPE server can be either kube control command line tool or the REST IPE client. As mentioned in the diagram, there are several plugins that are invoked by IPE server before creating, deleting, updating the object in the etcd. When we send a request for object creation operation to IPE server, it needs to authenticate the client. This is performed by one or more authentication plugins. Once the authentication is passed by any of the plugins, it will be passed to authorization plugins. It validates whether a user has access to perform the requested action on the object. Once the authorization passes, the request will be sent to admission control plugin.
Try to talk slowly, man. تحكي بزبط. بالنسبة للجماعة الأخرين علاش قلت لكم من important هي talking about cluster. نحن في الكول تاع الكلاب حكينا عن clustering اللي كوسكي كلاستر. هنا هي الماستر هذايا هو اللي كي va gérer le cluster. دونك بالنسبة لي الماستر اللي هو اللي قلت etcd اللي بتحكي عليه هو الانترفاس ما بينات الادمينستراتور اللي يقول أنا نحب السيرفيس نتاعي مثلا عندي vous avez défini un container, le container فيه مثلا site web والباز دوني نتاعو. donc les différents services موجودين dans un container. الكونتينر هذا نحب ديما معناها السيرفيس كي نقول دون كونتينر معناها اي واحد يحب ياكسيدي لابليكاسيون تاعو باش يلقى كل شيء في الكونتينر هذا. دونك ليوتيليزاتور فينال هنا باش يحكي على زوز اللي يعمل الديفلوبمون واللي يحب يعمل ديبلوامون. دونك il va accéder à travers الماستر يقول له راني نحب سيرفيس معناها عندي 2 ولا 3 containers اللي هما disponible وهما ديما accessible. دونك جي ديفيني هذا بعديك يولي الماستر اللي هو تبع كوبرنيتس il va gérer. طاحت ماكينه بالحق دونك يهز الكونتينر يحطو على في ام واحد اخر. فما شارج كبيره يزيد يصنع كونتينر جديد ولا فما ان بروبليم يصنع كونتينر جديد في بلاصه الكونتينر اللي تسد ولا اللي فيها ان بروبليم. دونك الجيستيون تاع الكلاستر الكل باش تصير في النيفو نتاع الماستر. دونك الماستر والوركر نودز دونك هو كلاستر باش نلقى فيه ان ماستر اي ماني وركر نودز. Les worker nodes هذوكم والماستر مع بعضهم they define a cluster. دونك اليوتيليزاتور باش يكون من جهه ادمنستراتور دونك يدخل الكلاينت ينجم يكون ادمنستريتور وينجم يكون اون بيرسون كي فو اكسيدي للسيرفيس دونك الكلاينت والديفلوبر والادمنستريتور هما 3 different users that could be defined. So here we are seeing what we have seen already in the course. That's why I said that it's important. So it's an application, it's an open source, Kubernetes, you can access to it. باش تستصنع cluster pour une application bien définie. Yes, you can continue just with a slower flow.
Okay, it's a habit. I'm sorry for that. Okay, so we stopped at the admission control plugins, which are responsible for initializing any mission field or default value. For example, if we didn't specify any server account information in the object creation, one of the plugins will take care about adding default service account to the resource specification. Finally, IPA server validates the object and stores it in the ATSD. Next, we have the scheduler. The scheduler main job is to allocate what nodes the pod needs to be created on. It registers with the IPA server for any newly created object and resource. Scheduler figures out what nodes the pod needs to be created using an algorithm. It checks whether the worker node has desired capacity or not, and it checks whether the resource specification targeted any specific nodes. Finally, after figuring out the nodes, the scheduler will just update the resource specification and send it to the IPA server. The IPA server updates the resource specification and stores it into ETSD. The IPA server notifies the Kubel about the worker node scheduled selected by the scheduler. And finally, for the master, we have the control manager, which is responsible to make sure that the actual state of the system converges towards the desired state, as specified in the resource specification. There are several different controllers available under control managers. All controllers go to the IPA server for change to resource objects and perform necessary action to create, update, delete of the resource. Next, we have the worker node components with Reem.
So for the work node, we have two components, Kubelet and Docker. So for Kubelet, it's a kube control that registers the node it is running with the API server. Kubelet monitors the API server for pods and that are scheduled to the node, and then it will start the pods containers by instructing the Docker runtime. Kubelet monitors the status of running containers and reports to the API server about status, events, and resource consumption. Kubelet will also do health checks for the container and restart it if needed. So for Docker, it was the container runtime used by Kubelet for spinning up containers. Docker is a platform for packaging, distributing, and running application. It is based container images contain application code, file system required, and application metadata. The Docker registry is a repository that stores Docker images and allow us to share the images over the internet as public and can be public or private.
Next, we have OpenShift. So what is it exactly? OpenShift is a hybrid cloud platform for Kubernetes, an open source container solution to deliver applications that work on blockchain technologies and complex artificial intelligence systems, like IBM Watson. OpenShift helps to simplify and automate the cloud-based capabilities of Kubernetes, making new releases, migration, and development much faster and easier. OpenShift is a turnkey enterprise-grade, secure, and reliable containerization solution built upon source Kubernetes. It is built on the open source Kubernetes with additional components to provide out-of-the-box self-services, dashboard, automated CI and CD, container image registry, multilingual support, and other Kubernetes extensions. Then we have the building blocks of the OpenShift.
OpenShift consists of the following layers and components, and each component has its own responsibilities. We have the infrastructure layer, the service layer, the main node, the worker node, the storage, the registry, and the routing. The infrastructure layer. In the infrastructure layer, you can host your application on physical servers, virtual servers, or even on the cloud, private or public. In the service layer, It is responsible for defining pods and access policy. The service layer provides a permanent IP address and hostname to the pods, connects applications together, and allows simple internal load balancing distributed tasks across application components. There are two types of nodes in an OpenShift cluster, main nodes and worker nodes. Applications reside in the worker node. In the main node, it is responsible for managing the cluster and it takes care of the worker nodes. It is responsible for four main tasks. The API authentication. Any administration requests goes through the API. The data store stores the state and information related to environment and application. The scheduler determines pad placements while considering current memory, CPU, and other environment utilization. Health and scaling monitors the health of pads and scales them based on CPU utilization. Now the worker nodes. The worker nodes are made of pods. A pod is the smallest unit that can be defined, deployed, and managed, and it can contain one or more containers. These containers include applications and their dependencies. For example, Alex saves the code of her e-commerce platform in containers. For each, the databases, front-end, user systems, search engine, and so on. The registry. The registry saves your images locally in the cluster. When a new image is pushed to the registry, it notifies OpenShift and passes image information. The persistent storage. Persistent storage is where all of your data is saved and connected to containers. It is important to have persistent storage because containers are ephemeral, which means when they are restarted or deleted, any saved data is lost. Therefore, persistent storage prevents any loss of data and allows the use of stateful application. And finally, the routing layer. The last component, it is the last component and it provides external access to the applications in the cluster from any device. It also provides load balancing and auto routing around unhealthy pods. So let's see the difference between Kubernetes and OpenShift v3.
So both Kubernetes and OpenShift feature robust and scalable architecture that enables rapid and large-scale application development and management. They both run on the Apache License 2.0, and that's just about where the similarities end. Here are just a few of the many ways OpenShift and Kubernetes differ. So the first difference is product versus project. Actually, while OpenShift is a popular product, Kubernetes is a framework or an open source project. OpenShift allows the users to install the product that offers paid support with a subscription. The subscription is inclusive and cloud forms, which further help in enhancing the features of the product. The users need to renew the subscriptions for their cluster, and the amount increases with the expansion of the cluster. Kubernetes is a project that has a self-support model with several side projects, a community, and a whole ecosystem. It offers users the support of external experts and the community in problematic situations. The second difference is flexibility. In terms of flexibility, Helm charts of Kubernetes is more flexible than the templates of OpenShift. The usage of state-of-the-art templates and packages in the Helm charts is hard to deploy on the OpenShift. The automation broker on service catalog available on the OpenShift can be easily installed on Kubernetes. But Helm cannot find support on the OpenShift. This creates difficulty for the users to work with the inflexible templates of the former. The third difference is security. The security policies of OpenShift are stricter than the Kubernetes. The OpenShift platform forbids the running of most container images as well as many official images. It is easy for people to run simple apps on the Kubernetes, but the security policies of OpenShift restrict them to do so. A certain level of permission is required to maintain the minimum security level, which can be provided by OpenShift. With the use of OpenShift, users do not have any choice but have to learn the policies to deploy more apps. Moving on to fourth difference, which is deployment approach. The approach towards deployment is another difference between OpenShift and Kubernetes. While Kubernetes has deployment objects, OpenShift has deployment configuration. The deployment objects are internally implemented by controller and are used for updating pods. On the other hand, the deployment config is not implemented by controllers through dedicated pod logics. While dealing with multiple and concurrent updates, it is wise to choose deployment objects as deployment config does not support it. The fifth difference is router versus ingress. The router objects in OpenShift and ingress in Kubernetes also almost perform similar kinds of jobs. All dang good HA proxy implements the router on OpenShift, but the ingress on Kubernetes offer more choice as multiple different servers can easily implement it. Although the router lacks many features of ingress, it is still considered to be more mature. The Kubernetes offer different enhancement options. In this aspect of Kubernetes versus OpenShift, though both perform great, the router outweighs ingress due to its maturity aspect. Sixth difference is management. Image streams of OpenShift makes the management of container images easy. This is also makes the changing of tags for images in the container register simply. It allows downloading of whole images and changing them locally without the use of any external tool. In terms of management of OpenShift versus Kubernetes, the image stream of OpenShift stands out the best. The user experience, the users still find it hard to learn and manage the containers due to the complex and cutting-edge interface. OpenShift offers support to the users for logging into clusters, but with Kubernetes, users require external tools to obtain credentials and create files. With the OpenShift, switching between project or namespace is easy, but the Kubernetes require additional tools. Actually, in OpenShift, a single command user can build container images and use them in different environments, but it's difficult in the case of Kubernetes. The eighth difference is integrated CI and CD. The integrated Jenkins on the OpenShift did make the deployment of apps easy. It offers support for source-to-image, helping the users create custom-made Jenkins images that allow the easy update. The integrated Jenkins also makes management, upgrades, and testing easy. Synchronization also become easy through this integration. The ninth difference is networking. It is another important point which is important to consider in OpenShift versus Kubernetes. Kubernetes deals with the network traffic in an abstract way. Though some components of Kubernetes do not have their native networking solution, they offer the third-party plugins. With the use of these plugins, users can perform their different tasks, but OpenShift offers its native networking solution to the users. The Open vSwitch of OpenShift is an out-of-box solution that has its architecture that offers the user three different plugins. The three plugins are OVS Subnet, OVS Multi-Tenant, and OVS Network Policy. Hence, OpenShift outweighs the Kubernetes in terms of networking. And the last difference is service catalog. In the case of Kubernetes, the service catalog forms an optional component that requires separate installation. After the completion of the installation, it again requires to get into contact with the existing service broker. The service catalog provided by the Kubernetes has less provision for services within clusters. It has better provisions for managed services. OpenShift offers a service catalog that has two default service brokers. It also allows the user to integrate another service broker for the managed services, as in the case in Kubernetes. The service catalogs of OpenShift allow the comfortable deployment of selective applications by the users, and in the difference, the layer proves to be better in terms of the service catalog. Now we move on to the Kubernetes use cases.
For the Kubernetes use case, we have Bloomberg. It's a financial data specialist turned to Kubernetes in 2015, when a tool was still in the alpha before moving into production in 2017. Once the necessary continuous integration, monitoring, and testing was proved out. Bloomberg processes hundreds of billions of financial data points every day, with 14,000 different applications powering its ubiquitous terminal product alone. The IT organization wanted to boost the speed at which it could bring new applications and services to users and free up developers from operational tasks. After assessing various orchestration platforms such as Cloud Foundry, Marathon, and various Docker offerings, Boomerang opted for Kubernetes. Over time, Boomerang has worked on the homegrown platform as a service layer on top of Kubernetes to give developers the right level of abstraction to work effectively with the technology. The self-service web portal is essentially a command line interface and API, and the REST API, which integrates with the gate-based version control and continuous build system. One of the key goals of Bloomberg was to make better use of existing hardware investment. Using the outscaling capabilities of Kubernetes, they were able to very efficiently use the hardware close to 90 to 95% utilization rates. Much of that efficiency comes from the ability to constrain resources for a given workload so it doesn't strafe other workloads. As it is the case of the most enterprise adopting Kubernetes in production, the main challenge arose around using the YAML to write manifests, which specify how Kubernetes allocates resources. The YAML.yaml is a YAML-based schema definition on how to map external ports, directories, environments, variables, and various configuration options for a custom image. This is why we said it controls how Kubernetes allocates resources. As a result, Bloomberg started with a basic manifest limited to a small subset of criteria from which developers could scale up their usage as they got more comfortable with the technology. The orchestration platform is being targeted at web-based applications and net new systems. In the data and analytics infrastructure team, the initial approach was to stand up a new data science compute platform for the machine learning engineers to run complex workloads using tools like Spark and TensorFlow. Then we have the OpenShift use case.
OpenShift use case, we choose to discuss the case of Slovenska Sporitelnia Bank. Meeting customer demand for modern banking feature, part of Erste Group Bank, Slovenska Sporitelnia is the largest retail bank in Slovakia. The 100-year-old bank offers a wide range of banking services to more than 2.2 million customers, including an online and mobile bank. With rising demand from customers for more modern features in its product, the bank needed a way to release new features more quickly and more often to stay competitive. To shorten its service development cycle, reduce frequent outages and due to bugs, and simplify management of its application environment, Slovenska Sporitelnia sought to adopt a container and microservices-based IT architecture supported by a collaborative DevOps approach. Adopting an enterprise container platform with the DevOps approach when looking for an enterprise open source container platform that would provide reliable IT infrastructure, the bank chose Red Hat OpenShift due to its reputation for stability and the availability of local support. Red Hat OpenShift provides a modular, flexible platform and built-in automation capabilities for SLSP's development, testing, and production environment. The bank also adopted Red Hat Ansible automation platform to create a playbook for automating time-intensive manual provisioning tasks. SLSP began a three-phase approach to its business transformation. The first phase focused on establishing cross-functional agile teams that included analysts, business users, developers, and engineers. Next, during the process phase, these teams worked together to optimize deployment processes and move from quarterly to monthly releases. The final phase focused on tools included on-premise implementation of Red Hat OpenShift and Ansible automation platform. During this phase, SLSP's team worked with ELOS Technology, a local Red Hat Platinum partner, and Red Hat Consulting to standardize and automate application development and deployment processes, as well as orchestration tasks for the bank's private cloud. SLSP also engaged Red Hat training to provide instruction on best practices for OpenShift administration. The first application developed on Red Hat OpenShift was transparent accounts, used by Slovakian politicians to disclose financial information such as funding sources. While the first application was deployed in a public cloud environment on OpenShift Online, SLSP has since adopted Red Hat OpenShift Container Platform running in an on-premise environment. That's all. Thank you.
Thank you very much for your presentation. I think it's clear. All the building blocks of OpenShift and Kubernetes are clear for me as a listener and of your presentation. I don't think if there's some question from your fans. So for the Kubernetes here, you said that can we use or how we can, if I'd like to use Kubernetes, what I should do?
There are different ways to use Kubernetes. We can use it on the internet, or we can install it. Like there are things called Minikubes and such, which we can install it locally on our computer and we can run it.
Have you tried to use it?
We followed some tutorials,
yeah,
but
we
the
just
coding...
we've seen some tutorials, but we did not actually run.
Okay, and it's clear that you said it in the last and the end of your presentation that OpenShift is a Red Hat product. So that's why I'm asking you about Kubernetes. So here, OpenShift will build on Kubernetes to offer new services. I think that the comparison that you have said, that the advantages of the comparison between them is very good. So just I would have appreciate if you have added some figures at this side. You have explained it very well, but just if some figures could make these advantages more clear. But OpenShift will build on Kubernetes, so we'll add other features related to the service management, as you said, on the Kubernetes. I will, so thank you for the presentation. It's a good presentation. I appreciate it.
Thank you.
Thank you.
So we can go now to Walza and
Yes.
Arish, Muhammad, and Ramzi.
Yeah. I think you can see my screen now.
Yes, now yes.
Okay, so hello everyone. Today we are going to talk about the Streambox and Woza. We are going to talk first of all about the basic concepts. What is a Streambox and what is Woza? Then the building blocks of the cloud streaming. Then we are going to talk about the architectural differences of Streambox and Woza. After that, we are going to talk about some use cases. So what is a Streambox? A Streambox is a powerful media device which connects to your HDTV via your broadband internet connection, bringing you an enormous range of high-quality streaming entertainment directly to your living room, completely free of charge. Founded in 1999, Streambox is an industry-leading pioneer delivering a unique IP-based video streaming solutions over low bandwidth connections. So once you have purchased your Streambox, there are no monthly fees, no contracts, no charges ever again. Streambox brings you endless amounts of movies, TV shows, live TV sports, kids-friendly entertainment, UK TV catch-up services, music videos, personalized streaming music, and hundreds of live radio and TV streams from all over the world. You can even view your own favorite photographs and mobile phone videos on your HDTV directly through your Streambox. If you like watching YouTube, why not watch it on your big screen TV with your whole family and friends? And now moving to WOZA. So what is WOZA? WOZA is a unified streaming media service software developed by WOZA Media Systems. The service The server is used for streaming of live and on-demand videos, audio, and rich internet applications over IP network to desktop, laptop, and tablet computers, mobile devices, IPTV set-top boxes, internet-connected TV sets, game consoles, and other network-connected devices. The server is a Java application deployable on most operating systems. WOZA streaming engine can stream to multiple types of playback clients and devices simultaneously, including the Adobe Flash Player Microsoft, the Apple QuickTime Player, the Microsoft Silverlight Player, and iOS devices. Also, and game consoles such as Wii, Xbox, and PS4. Moving to review the building blocks of the cloud streaming.
There are 4 building blocks of cloud streaming. We have the message broker, the stream processor or streaming data aggregator, data analytic engine, and lastly, streaming data storage. So first for the message broker, it is the element that takes data from a source called producer, translated into a standard message format and streams it on an ongoing basis. Other components can then listen in and consume the message. Messages passed on by the broker. The first generation of message brokers as RabbitMQ and the Apache ActiveMQ relied on message-oriented middleware paradigm, MOM. But later, high-performance messaging platforms emerged which are more suitable for streaming paradigms. Two popular streaming brokers of them are Apache Kafka and Amazon Kinesis Data Streams, and they are the most known ones of the hyper-performant ones. Like the old MOM brokers or message-oriented middleware brokers, streaming brokers support very high performance with persistence and have massive capacity of a gigabyte per second or more of message traffic, and are tightly focused on streaming with no support for data transformation or task scheduling. Then moving on to stream processor or streaming data aggregator. The stream processor collects data streams from one or more message brokers, so it comes after the message brokers and uses it. It receives queries from users, fetches events from message queues, and applies the query to generate a result. The result may be an API, an application programming interface, a call, an action, a visualization, an alert, or in some cases, new data streams. A few examples of some stream processors are Apache Storm, Spark Streaming, and WSO2 stream processor. While stream processors work in different ways, they are all capable of listening to message streams, processing the data, and saving it to storage. Some stream processors include Spark and WSO, provide an SQL syntax for querying and manipulating the data that they get. And we will discuss then the data analytic engine. After streaming data is prepared for consumption,
by the stream processor. It must be analyzed to provide value. You can just keep it like that as data. You need to analyze it to get the most value out of it. There are many different approaches to streaming data analytics, and the tools mostly commonly used for streaming data analytics are Amazon Kinesis, Google Cloud Dataflow, Azure Streaming Analytics, IBM Streaming Analytics, Apache Storm, and Stream with double I. There is also StreamSQL. Lastly, for streaming data storage, with the advent of low-cost storage technologies, most organizations today are storing their streaming event data. There are, let's say, three well-known types of data storage options. We can store the data in a database or data warehouse, in the message broker, or in a data lake. So I'm gonna talk briefly about the pros and cons of each one of them. In a database or data warehouse, for example, PostgreSQL or Amazon Redshift, it is well known. Its pros are easy SQL-based data analysis, but it is hard to scale and manage. And if it is cloud-based, the storage is going to be expensive. Second, we can store data in the message broker, for example, using Kafka persistent storage. It is no need to structure data into a table, easy to set up, no additional components. But data retention is an issue since Kafka storage is up to 10 times more expensive compared to data lake storage, which we're going to talk about lastly. Kafka performance is the best for reading recent data. So there is a problem of data retention. Lastly, in a data lake, for example, Amazon S3, the most used one. The pros are it is agile, no need to structure data into tables, low cost storage, but it has high latency, making real-time analysis difficult. And it is difficult to perform SQL-based analysis. The data lake is the most flexible and expensive option for storing event data. It is the most used, but it clearly has several limitations for streaming data applications. That's it for the architecture.
Okay, we're going to talk about some key differences of streaming books and WOZA. There are many differences between live broadcasting and live streaming, and different goals like reach, engagement, restriction, feasibility. In order to do that, WOZA and Streambox use different protocols. For example, WOZA uses WebRTC. WebRTC is a streaming protocol. His main purpose is reducing latency to 1 or 2 seconds. These streams can be transcoded and broadcasted as HLS or dash streams at normal latency. You will also lose the quality and features available with HLS/dash based streaming. WebRTC comes with multiple development costs and other limitations that make it unsuitable for most traditional live streaming broadcasters. Although for Streambox, all Streambox broadcasts come occupied with Streambox exclusive low delay multipath technology, or LDMP. LDMP protocols allows for low latency adaptive bit rate streaming over public and private networks. Next slide, please.
Oh, sorry.
So also for Streambox, there is IP-based video allows each machine in an IP-connected environment to act as a standalone source and to act as its own switchboard of sources. Every live streaming source can be cut into any other live broadcast in any machine connected to the IP video environment. Streambox Streambox focus on IP-based end-to-end news gathering and contribution of services. Next slide, please. Next slide. Okay. The open source protocol is recognized as proven alternative to proprietary transport technology, helping to deliver reliable streams regardless of network quality, from covered lost packets to preserving timing behavior. SRT was designed to solve the challenges of video contribution and distribution across the public internet. Although it's quickly taken the industry by storm, SRT is most often used for first mile contribution rather than last mile delivery. That's it.
So now we're gonna talk about a specific use case, an example using WOZA. For space, the 1969 moon landing lives on as the most iconic event in television history, and today the live video transmission continues to power space exploration in a number of ways. NASA built WOZA into their reliable, secure streaming and infrastructure. For NASA, WOZA delivers video from the International Space Station to both internal researchers and the public. This allows NASA to effectively manage who has the access to confidential streams and easily broadcast streams intended for the general public. WOZA flexible technology helps ensure this versatility, and its proven stability gives NASA the peace of mind required when broadcasting from space. Also, in the space exploration realm, SpaceX, the famous Elon Musk company, relies on WOZA for different capabilities too. As the video solution for their mission control center, this technology helps ensure that their launches go smoothly and successfully by streaming low latency video back to the ground segment of their spacecraft operation. So both NASA and SpaceX, two infamous companies, use WOZA or used and they still use WOZA in some of their, let's say, operations. And that's it for the specific example of the NASA's moon landing and SpaceX.
Moving to another Streambox example is the Gospel Channel case. Well, Streambox Gospel Channel, a Christian TV station in Iceland, needed to send high-quality video between its US and Scandinavian studios. Using a Streambox with its low bandwidth consumption, reliable point-to-point connections, high-quality image, and low-cost transmissions over Streambox cloud services was the perfect solution. Well, I'm sorry. Gospel Channel was the first station in Scandinavia to broadcast Christian content. Now, after 24 years on air, from their studios in Iceland, Norway, and Florida, Gospel Channel can reach 80% of Iceland's population through transmitters and cable systems, as well as 12 million homes in the UK and Scotland through satellite. Well, that's it for our presentation about Streambox and WOZA, and thank you for your attention.
Thank you very much. So as you said, the Streambox and provides stream traffic and video across the internet, across the based on the cloud. So you have presented the different building blocks. You said that you will construct from different sources. You can construct new videos. You can distribute them. You can store them and analyze them. So I'd like to ask about the analytics, data analytics engine that you have presented. How what have you or how analysis can be done on videos and on the different videos and the streaming data that you have collected?
Where for analyzing
Yes.
data after
Exactly.
collecting.
You said there is a slide related to data analysis engine before this. So
Yes.
you have storage, analyzing, and you have
Yes.
the.
Yes.
So analyze is based on what? How you can analyze it?
So after the streaming data is prepared for consumption by the stream processor, it needs to be analyzed to provide value. So after you get after the message broker does its job and the stream processor or data aggregator does its job, then we need to analyze data to, let's say, get if you only get data from user, there is user that I don't know, put data that will result in an API call, an action, a visualization, an alert. That's the job of streaming data aggregator. And there are people that send messages, normal messages that doesn't require the streamer processor streaming data aggregator to interfere. But then if we have all this data and we just store it without getting actual value from it, we're just losing out. So we need to analyze this data to know the preference of the users, or let's say it can be used to let's say modify our operations. Let's say if people or to integrate a new let's say what they are called
What
new
kind
options.
what kind of analysis we can do? Example.
There are the types of the data analytic engines, you mean, or the type of analytic we're gonna do?
Exactly. Samples of the data analytics related to the videos that you have collected or the streaming data that you have collected.
Let's say we can. So we can see how many people are integrated in the video, how many people like watch it more than 30 seconds, more than 1 minute, more than 2 minutes. So if we get the population of people that are viewing our streaming data and how they are interacting with our data, and how they are interacting also by their, let's say, messages or commands, we can then, let's say, personalize the videos that we're gonna stream. Also, this works to know which videos are what.
All this is related to the utilization or the access to the data. Is it possible to analyze the content of a video?
Is it possible to what?
To make analytics related to the contents of the different videos. You have different videos that are stored in the cloud, and you'd like to make some analysis related to special content. حاجتك بكونتوني معين، اسكو سي بوسيبل ولا جاكسيد ولا نعمل اناليز على وسط معناها شنو موجود في وسط الفيديو؟
Firstly, video. Honestly, I don't know about this, but I know the analysis is done based on the reactions to the, let's say, the users to the videos. I don't know if the analysis is in some cases used to analyze the video in itself, but I know it is analyzed in accordance with the reactions and the viewers of the video. In that way, we can see, well, we can use that to know which part of the video are more interesting, which part are gonna leave an impression or they are making an impact on the users. And by that, we can know which parts of the videos are good and which parts are bad. I don't know if that satisfies, answers your question.
So another question related to how does Dreambox and those that get benefit from the cloud? Why these kind of applications or this kind of are now possible using the cloud? How they get benefit from cloud computing? Is it possible to offer these kind of services if you hadn't have the cloud?
For one thing, they make use of the cloud in their data storage. There are plenty of data, a huge amount of data going in and going out every second. So they need to store. If they need to store the data, they can. They have two choices. They can. Three choices, as I said: data or database or data warehouse. It doesn't use the cloud, or in a message broker. It doesn't use the cloud too, but they can use the cloud in the data lake if they store their data in a data lake, which is the most commonly used for WOS and Streambox. It is the most flexible and expensive. It has limitations, which is high latency and which makes real-time analysis of the data difficult. But it is, as I said, the most inexpensive option and the most flexible option. So they tended to use that. So to answer your question, they can not use the cloud. But that's gonna be they're gonna be limited on their data storage and how let's say it's gonna be expensive for them to not use the cloud, because in a data house or a database or data warehouse is gonna be more expensive. And in the message broker, there is a problem of data retention. And it's 10 times more expensive than a data lake.
Excuse me, what do you mean by message broker? Could you explain it more? Message broker. So because as I understand from what you have presented, it's a broker that is defined in the cloud. So you look for some resources inside the cloud. Is it true, or I have misunderstood?
No, the message broker is the element that takes data from a source called the producer, the one that produced the videos or streams it, to translate it into a standard message format and streams it in an ongoing basis. That's it. That's the simplest definition I can give. Then the other component, listen and
even the message broker is defined in the cloud because you connect using you will reach different source providers which are defined. So you will use the cloud. You will use the network service provided by the cloud, and you will construct over it. You will define or construct after even the construction will use the resource of the cloud. So just to make حبيت نصلح خاطر انت قبيله من الكلاود you said that you will use only storage but not only.
No, I just said in the case of storage, they can use the cloud. If they don't use the cloud, in the case of storage, it's going to be so expensive and it's not practical or efficient. So using the cloud, even though it has a limitation in the data lake, it's going to be more flexible and less costly. I think I didn't.
It's not the unique place when you use that.
Yes, totally agree.
Okay. Thank you very much for the presentation. It's a very good presentation. So thank you for your work. And now we'll finish with the last one, which is Aziz, Amin, and Amin for the Luminity and Storm proxies. That's it. Wael and Amin. Aziz, Wael, and Amin. So here, Wael.
اي مدام انا هون.
وي مدام لحظه برك جست نبارتاجي ليكرون. Can you see my screen?
Not yet, Wael.
No, not yet. Yes, now.
Yes.
No, yes, okay.
Hello everyone. Today we are going to talk about Luminati and Storm proxies with Amin Said and Wael Gargouri. In this presentation, we will be dealing with definition of proxies, the basic concepts, the building blocks of proxy services, the architectural scenarios of proxy services, and some deployed use cases. In this data era, almost every business either needs to or already does collect information from the internet. However, websites block or display misleading information if they think a particular user is using a free proxy service or a bot. Websites identify these users when the IPs are all part of the same subnet block range, when the IPs are found on a known proxy list, or when too many requests are sent from the same IP. VPNs and proxy servers both protect user identities and are great tools for accessing geo-restricted content. Since both of these services can get the job done, people tend to speak to them interchangeably. However, one protects your privacy and the other one does not.
So here, quick comparison between the proxy and VPN. So the VPN encrypts your traffic while the proxy servers don't. So a VPN service will protect you from the internet service provider tracking, government surveillance, and hackers. Proxies don't. So they should never be used to handle sensitive information. Second, the VPN works on the operating system level and reroute all your traffic while proxies work on the application level and only reroute the traffic of a specific app or browser. Third, the VPN can be slower than proxies because they need to encrypt all the data. So there are some ways you can improve your connection and browsing speeds with using the proxy. Fourth, the VPN are usually paid, so you can't trust any free service as they have limitation and tend to mine your data. So while proxy services are free, the VPN connection is more reliable, while the proxy connection is can drop more frequently.
So now moving to the next slide, the brief basic concepts of Luminati. So Luminati is the world's leading proxy provider and the largest proxy service. It's also the only proxy company I've seen to call itself an ethical proxy network. In the market since 2014, the Israeli provider has grown an array of features and infrastructure around it. You won't have any trouble finding any kind of proxy or protocol anywhere in the world. You'll have a powerful dashboard to configure your proxies and 24/7 customer support in case things go wrong. You'll also be assured that the company serves Fortune 500 enterprises.
Looked at purely from the point of view of features, there's not much that Storm Proxies has to offer. This is nothing compared to the bigger players like Luminati. But the thing about this proxy service provider is that it's greater than the sum of its parts. Not only is Storm Proxies well aware of its offering, but it's also refreshing to see a service not try to hide its limitations behind fancy marketing copy. Still, the company has carved itself a comfortable niche with a surprisingly loyal following. Storm Proxy pitches itself at small-time scrapers, social media managers, sneaker copper, add in a few well-placed ads here and there, word-of-mouth recommendations, and suddenly Storm Proxy's popularity starts making sense.
So the access point consists, the building blocks of Luminati consist of a crawler sending HTTP or HTTP requests via an API or a browser to the super proxy via a middleman crawler called proxy manager that help you control your traffic and manipulate your requests. Now, the super proxy is a network loading balancing server that will send the requests to the available IPs in the Luminati proxy network. The super proxy stripes down your IP into the network details and send the request to the desired exit node on the proxy network, which is called the proxy peer.
Next slide. So Luminati offers a whole range of services. Data center IPs. Luminati's data center proxies include both shared and dedicated IPs. The provider boasts having around 770,000 addresses across 3,000 plus subnets. They're located all around the world, so you shouldn't be having any issue finding any an IP even in a more exotic place. The private data center proxies don't rotate by default, but you can set up rules for rotation using Luminati's brilliant proxy manage.
Moving on to residential proxies. Residential proxies are Luminati's forte. With over 72 million IPs under its belt, Luminati has the largest rotation residential proxy pool in the world. They cover all countries and thousands of cities, so location targeting won't be an issue. The proxies come from desktop and mobile devices for real users. Luminati acquires the IPs by burying its code into popular apps with or without people's knowledge. This means several things. The IP numbers fluctuate day by day. Luminati can't ensure their availability. The proxy pool is shared between all users. Luminati's residential proxies cover all the main protocols, HTTP, HTTPS, and SOCKS 5. The residential IPs come from their sister service, which named as Hola. Hola is one of the most popular free residential VPN servers. Hola is almost like Tor, as it can transfer traffic by acting as a proxy node for Luminati users.
Now, for the third type of proxies, there are mobile proxies. So I have particularly sophisticated needs or particularly hard to targets, like for Instagram. So Luminati can offer you around 7 million IPs from 3G or 4G powered mobile devices. So these IP addresses are cover most of the world and can be freely target the countries and cities you like. Not only that, but you can also have the option to select a particular ASN or even a courier. So the mobile proxies come from device of end users. So they are not invariably rotated. You can specify the session time that you like, and Luminati also offer an option to get private mobile proxies. They range from 3 to 30 IP addresses reserved for exclusive use.
On the other side, Storm proxies offer rotating residential proxies, private dedicated proxies which offer data center IPs, and back connect rotating proxies which have a mix of data centers and residential IPs.
You will get IPs that you need to enter inside any software that should make a proxy connection. By accessing your IP switcher or gateway server with those IPs, you will receive a new proxy IP on each HTTP request or after 3 minutes or 15 minutes. It depends what proxies you choose from inside the member area. The maximum number of threads, or what we call connections, that you can open in your software tools is limited by the package that you order. For example, an 80 threads package allows a total number of 80 simultaneous connections. Inside the member area, there are 3 types of proxies. The main proxies, where the IP changes each HTTP request, 3-minute proxies, where IP changes every 3 minutes, and 15-minute proxies, where IP changes every 15 minutes. What you see inside the member area for each of those 3 types of proxies are IP for the gateway server. The IPs never change. By using these IPs from the browser or any other software, you are accessing the proxy gateway that rotates proxy IP and takes new random IP for each request. On this way, remote sites that you access does not see your real IP address, but some of IPs from the big proxy IP pool.
The best thing about Storm proxies is that all the proxies come from unlimited bandwidth. Instead, its private dedicated proxies limit accounts on the number of IPs. The back connect rotating proxies based plan on the number of simultaneous connections, while the rotating residential proxies with prices ranged from depending on the number of ports. Each port is capable of running up to 50 simultaneous connections.
The back connect rotating proxies come from a pool of 70,000 IPs and only allow you to choose between 3 broad regions, namely the US, the EU, and worldwide. These are back connect proxies that are served via different gateways, each with its separate rotating time. So the 5-minute rotating residential proxies come from an even smaller pool of around 40,000 IPs. They only cover the US and EU locations and don't allow you to choose which countries or cities you want to target.
For Luminati performance tests, the IPs showed great results in most benchmarks. They had extremely high success rates. However, only around half of the requests to Google went through. As we found out later, you need special arrangements to access the search giant. The same happened with several more of our tested websites. When the residential proxies are under stress, something unexpected happened. They slowed down considerably and the success rate dropped. In proxy quality tests, none of the tools we used revealed Illuminati's residential IPs as proxies. This is a good result, as it shows that the proxies are hard to detect and they won't leak out your own IP address.
Compared to the market leader, the performance of these residential proxies failed to impress, because Storm proxies displayed a mediocre success rate, with only 200 current connections. Only 40% of the requests went through, compared to the 90% by Illuminati, which is not that much at all. So I wouldn't suggest pushing these proxies very hard. The hardest target for Storm proxies to crack was Google. On every fifth request managed to success, and almost half of the failed requests were blocked. On the bright side, the proxies worked much better with unprotected websites like Amazon. So there are no IP leaks for these for Storm proxies, but one website managed to recognize an IP as a proxy.
So we conclude that for Illuminati, the pros are a huge proxy pool, many features, powerful proxy controls, trial and money back guarantee. The cons would be expensive, can be very hard to use, and strict KYC procedure.
Moving on to Storm proxies. For the pros, we have unlimited bandwidth, it's inexpensive, and specialized plans. For the cons, we have small proxy pool, no location targeting, and average performance.
So for the Illuminati architecture and scenarios of proxy service, so a proxy service is similar to a waiter in a restaurant. They take your order and deliver it to the pastry chef, cook, and then get it back to the customer. In doing the restaurant is able to ensure each employee receive information relevant to them and can offer enjoyable, seamless dining experience. The waiter in this scenario is the proxy server, and the customer ordering food are the users of the service itself. The exit node are different areas within the restaurant, all contributing their own part, and in the end, giving the customer what they ordered. The exit node are the specific IP address the proxy service provide as a replacement for your IP.
Within a proxy network, the proxy server acts as a gateway, forwarding requests from the user of a proxy to any number of outbound nodes before being sent to the target site. The exit nodes are alternate IP addresses, and by exchanging one IP for another, you can appear as a completely different user in a geolocation of your choosing. In masking your previous IP, proxy users are able to verify the accuracy of information when collecting data, access content that is location-specific, such as advertisements or private or pricing information, and emulates different online environments when testing websites. Also, when you type in the address or URL of a site, you are requesting access to that domain. This request provides information to that specific domain from your device, cookies, and most importantly, the IP addresses. Your IP address is similar to a mailing address and contains information including how to send the information you requested back to you. The IP address provides location data, so the site can respond by providing the web page content relevant to you.
However, in many cases, it is necessary to emulate a different user by using a different IP address, and that is where proxy servers come into play. By using a proxy server, requests are sent from a user. These requests are received by a load balancing super proxy server, which forwards that request to the right exit node. These exit nodes are in the form of different IP types, and the request is then sent to the target site from the IP chosen. Shared IPs allow you to maximize value while minimizing costs. An example of this is when gathering data from sites which request limit blockade. A request limit blockade is a common security feature sites implement that detects and flags suspicious activity, such as too many requests too quickly from the same IP. This is normally used to prevent bots from crawling a site. These blocks can be avoided by changing the IP every X number of requests. By switching the IP, you can avoid being flagged, maintain a high success rate, and ensure continuous data collection.
So for the Illuminati use case, we'll be talking about how to create proxies for web testing. So to create the perfect testing environment, analysis need to simulate a real user. This can be done using the right types of software, correct device fingerprints, and the right geolocated IP type. A proxy network service in combination with the right automated tools make testing websites performance easy and most importantly accurate. You want to be able to test by various geolocation, but also if relevant to your adaptive content by different IP types, residential, mobile, and data centers IP addresses.
Another Illuminati use case here. So proxies for price comparison. Online price comparison. So retailers, travel sites, and e-commerce understand that e-commerce websites understand that price comparison is a critical part of daily operations. Companies price their products relative to competitors' prices to stay ahead of the game. These websites keep track and are aware when their competition is accessing their site and feed them the wrong information to keep prices competitive. They manage to overcome these blockades by mimicking a real customers. You can collect unlimited amounts of the most accurate data available. Luminati provides the world's most extensive, fastest, and most reliable residential proxy network. By providing access to real user IPs, you will be seen as a customer rather than a rival and be able to collect accurate pricing data in any country or city across the globe.
As you can see over here, not this slide. Yeah. As you can see over here, Storm Proxies doesn't have any notable customers. They are all marked as anonymous because no real cases, there are no real case studies were conducted from current customers.
So as you can see here, for the market share for market of proxies, you can see that Illuminati is the leader here, and Storm Proxies is far away more it is classified as content there, and it's not like they don't provide the type of service that Illuminati is providing. So as we can see here, Illuminati is dominating the market with 53.1%, while Storm Proxies is only having a market share of 2.7%.
So thank you for your attention, and we're ready for your questions.
Thank you very much for your work. Understood the topic. But just can we use Illuminati and Storm Proxies to increase, for example, the number of likes on websites or number of views on some content in the internet?
Madam, can you repeat the question?
Can we use these two, Illuminati and Storm Proxies, to increase the number of likes or the number of views in for some content in the internet, in YouTube or any other?
So didn't hear it, but what
اسكناش بنستعملهم just اسكناش بنستعملوا الستارم بروكسيز
نورمالمون يقول لي اللوجيك يقول لي خاطر هو كي معناها كان كي انت تعمل ريكويست معناها باش تدخل السيت، هو وقتها معناها مش باش يعمل هو باش يعمل اكسي 10 مرات ولا 15 مره، وقت اللي انت جست تدخل مره واحده معناها هو في كل مره يبدل لك الاي بي ادرس نتاعك جست وقت اللي انت تاكسيدي الحاجه هذيك معناها.
اكزاكتومون. اسكو نجم نستعملها هنا باش نطلع بين النمبر فلاك، نستعملها باش كل مره ياخذ ادرس اي بي تدخل دون مانيير ديفيرون اي يبا اوغمونتي. خاطر تعرفوا انتم تو في البارتي ريمونيراسيون معناها فما عباد تربح في الفلوس بالنمبر اوف فيوز والنمبر اوف لايكس دونك في اليوتيوب ولا في دوتر بلاتفورم. دونك اسكو لي تكنولوجي هذوما ستورم بروكسيز واللوميناتي نجم نستعملهم بور سيت معناها تقول لي مش وحدهم نزيد معهم حاجه، اما سي بوسيبل نستعملوهم ولا لا؟
باه مدام فور فما سيتات كيما نايك so they are publishing some rare sneakers each period of time like 1 month. So there are many people that and they put the quantity. So only 5 sneakers that are available there on the website. So many people use sneakers proxies, which are proxies used to mimic the Nike servers, so they can make a purchase with multiple IP addresses, and many people are succeeded in doing this and ordering many sneakers with these sneakers proxies.
ماشي فهمت بالكدا ولا معناها سنيكرز بروكسيز هما اللي اكزامبل نتاع دي بروكسيز اللي نجم نستعملوهم للبيت هذاك اني انا نطلع نمبر اوف فيوز ولا نمبر اوف لايكس.
مدام
انت شنو
بالنسبه
انت قلت لي جست لحظه برك باش ما بالكش يعني.
أي.
انا تو البيت نتاعي باش نشوف اني كل مره قاعد كل مره ناخذ ادريس اي بي مش نتاعي يعطيه لي لي بروكسي هذوما باش نكسيدي بهم من اون ريسورس. دونك الريسورس هذيك لازم تكون فيديو اكزامبل على اليوتيوب. اذا كان نستعملهم يعني نعرف اني باش نعمل ان بروغرام صغير من فوق معناتها كل مره باش اكسيدي لك نستعمل في الستارت بروكسيز باش نكسيدي لك الفيديو هذيك نطلع نمبر اوف فيوز. دونك اذا كان طلعت نمبر اوف فيوز معناها مولا الفيديو يبقى غاني دو لارجون. دونك اسكو نجم نستعملهم ولا لا في القاهره؟
مادام بالنسبه لليوتيوب ارونو مي بالنسبه معناتها لسيتات اخرى كيما معناتها مش في كال فيديو
نجم خاطر هو يوتيوب مثلا جونغ يحسب الفيو بالاي بي ادريس وانت بيسكو تبدل في الاي بي ادريس ياك دونك تنجم.
دونك انا جوست حبيت نقول لكم فما عباد تعمل في الفلوس ديجا تصنع بالبروكسي.
I want to mention also another example اللي هو ما نعرفش even in the elections ما نعرفش some parties يبداو يعملوا في لايف معناتها في لايف فيديوز على يوتيوب على شو اسمه على فيسبوك وكل and you see a lot of bots معناتها اللي هما ما همش réellement des comptes فيسبوك معناتها موجودين من اصله. you see a lot of likes a number of likes طالع بعد تلقاهم اسامي كلهم معناتها n'importe quoi.
C'est bien. Just a question. You said in the slide that you are, when you are talking about mobile proxies, and in this slide you said that you are using the IP addresses of some users without their knowledge. What do you mean? قلت قبيلة معناها تستعمل IP with or without their knowledge.
The IP addresses هذوما they are collected through Hola VPN. So Hola VPN is a free VPN posted by another company, which is a sub-company of Illuminati. People are using the VPN. They have access to the people, so they can use they can access many websites from blocked معناها areas وما يقراوش هما الترم اوف كونديشن اللي هي مكتوبه فيها that compromise and use for other purposes. And this IP address will be used through Illuminati to اسمع فيها مدام؟
اسمع فيك.
كان مقصود شويه الواحد قص. Madam, my friend is saying Illuminati, when they're checking they accept to share certain data, certain personal data, they're checking the box where they're sharing IP متاعهم Illuminati. Eventually Illuminati يقول لك that we can't ensure the availability متاع a certain number of IP addresses. Donc عندك البروكسي pool تلقاها is shared between all the users, and the IP number the IP address numbers are fluctuating depending on the day, depending on what's happening. Like eventually Illuminati acquires the IPs by burying its code into popular apps or with or without people's knowledge. Sometimes they take their consent, sometimes they don't.
Very good. يعطيكم الصحة. Très bonne présentation.
even application هذا even application اسمها earn money على على بلاي ستور ومعناها affiliated by Luminati which you can معناتها earn money by only opening this application and letting people use your IP addresses to access certain websites through your IP address معناتها اللي هي بلوكي مثلا في البرة، والا وقت اللي انت تستعمل هذاك البروكسي هذاك شراء برايسز اخرين اور معناتها اللي ترى فيهم انت على وقت اللي تدخل من برا، فهمت؟ مثلا ديزوتيل ولا حاجه. ذاتس ات.
معناها ميم كي نعطي الادريس نتاعي يستعملها دونك جو في غاني دو لارجون معاه.
اي ابلكيشن اسمها ايرن ماني كنت حاب
يعطيكم الصحة. تري بون بريزونطاسيون فيري جود عزيز وأمين وائل. ميرسي بوكو.
Thank you, madam.
هاي مدام.
عاش مدام.
فيري جود ورك. وائل نستنى من عندك سنة بروجكت تبعث لي
مدام هاك عملنا نحن اكسل شيت فيها الاول ذي واحد معناتها الاي تي ميجرز وتنحطوا لك مدام لينك دوك في كل شيء، ما انت كاو تدخلوا معناتها برايفت خاطر
يعطيكم الصحة. فرحانة بكم الحق الجروب الكل حتى مش لسه كل حاضرين. ويعطيكم الصحة مع خدمة باهية معناها there is a respect there is معناها فما سيريو فما الريسبي دونك للخدمة نتاعكم سورتو للخدمة دونك I hope that you have some additional value معناها فما you have earned some additional value from this course. بحثوا des skills بحثوا knowledge جديدة. Très heureuse de vous avoir renseigné. يعطيكم الصحة و I hope for you a very good future. إذا كنت تكملوا بالسيريو هذا تقولوا تربي vous aurez a very good future.
Thank you, madam. Thank you, madam. يعطيك الصحة لفور بتاعك زاد.
أي حاجة ولا أي دونك كيستيون من هنا الواحد دونك جو سوي ديسبونيبل لكم ولا لبقية أصحابكم. إذا كان فما أي معناها كلاريفيكاسيون ولا حاجة تحبوا تفهموها خير تنجموا تكلموني في أي.
اوكي
عايشك على رواحكم. اوكي
ميرسي.
باي باي.